all to the inauguration of our international online faculty development program on data science in education, enhancing research and curriculum. It is my privilege to
Yes, yes.
extend a warm welcome to our esteemed General Secretary Dr. Prabhakar sir and our respected Director Mrs. Sunita Prabhakar ma'am in their absence. A heartfelt a welcome as well to our principal, Dr. Arun Vikas Singh sir, our principal scientist and head R&D, director of IRIRC, Gopalan College of Engineering, Dr. K. Natarajan, our distinguished professor and convener, Dr. Manoj Chhala sir, and HOD of the CSE department, Dr. Swati ma'am. I am also delighted to welcome all the HODs of GCEM and the participants joining us from various colleges across India. Your presence truly enriches this gathering, and we look forward to an inspiring and engaging event together. As we begin this journey of learning and discovery, let us take a moment to appreciate the importance of knowledge and teamwork in shaping the future of education and research. We have an amazing group of expert speakers who will share their insights on data science and their impact on education over the next 5 days. To begin this event on a positive note, let us start with a prayer seeking blessings for wisdom, guidance, and success. I invite everyone to take a moment of spiritual reflection.
वक्रतुण्डमहाकाय सूर्यकोटिसमप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा सर्वकार्येषु सर्वदा.
With this auspicious beginning, let us now move forward with our proceedings. Let's start with the faculty development program. Firstly, I would like to invite Dr. Arun Vikas Singh, Principal of GCM, to deliver the welcome address. Sir, please.
Good morning, my dear participants, and I congratulate our CSE department to organize this particular event, that is data science in education. So, data science has become a key element in revolutionizing the educational sector. The increasing global investment in AI and data related domains have increased job opportunities in data field. As these advancements in the data science continue to grow and change the industry, it's a crucial for us to understand, examine its effect. One such area is the impact of data science on education in both teaching, learning, as well as the research field. Data science, basically it is an interdisciplinary field that uses the scientific methods, processes, algorithms, and systems to extract the knowledge and insights from the structured and unstructured data. In the simpler terms, the data science is about obtaining, processing, and analyzing the data to gain insight for many purposes. The main goal over here is to transform data into the information and information into insights. So, it's a 5 days FDP. So I would like all the participants to take the take this particular opportunity to enhance their skill with respect to data science. Thank you very much.
Thank you so much, sir, for your encouraging words and for laying a strong foundation for this event. Now, I would like to invite Dr. Manoj, sir, to share his insights.
Yeah, thank you. Yes, good morning to everyone. I would like to extend my warm invitation to all the esteemed faculty members for participating in our International Faculty Development Program on Data Science in Education, which enhance the research and curriculum. So in today's education landscape, data science as an emerging transformative force. So as our principal sir has mentioned, we can reshape that with a curriculum design and integrating with the data-driven insights, which enhance the teaching and learning experiences. And as educators, it is essential for us to embrace these advantages and equipping ourselves with the necessary tools and techniques to stay ahead in this digital age. This FDP is designed to provide valuable insights into how data science can be effectively immersed in academia. Through expert-led sessions, hands-on workshops, and the interactive discussions, participants will gain practical knowledge and also the technical knowledge in incorporating data analytics in research and the curriculum frameworks in education. So I encourage each one of you take advantage of this opportunity to enhance your expertise and contribution of advancement of education through data science. So your participation will not only strengthen your teaching methodologies, but also inspire students to engage with the data in meaningful ways. So I'm looking forward for an enthusiastic participations. And also I would like to congratulate all the organizing team who are behind in organizing this FDP, international FDP. So thank you very much.
Thank you, sir, for your valuable message. Lastly, I invite Dr. Swati, HOD of Department of CSE, to address our gathering and extend a warm welcome to all. Swati ma'am, please share your thoughts with us.
Thank you, Preeti. Good morning, everyone. So welcome to this International FDP on Data Science in Education. First of all, I want to thank our management, Prabhakar sir and Sunita Prabhakar ma'am, for their constant support and guidance. Special thanks to our principal sir, Dr. Arun, for his encouragement to conduct these kind of activities. So as all of you are aware that today's buzzwords are AI and data science, and our main focus of this FDP is to integrate data science to curriculum and research. So we also have eminent speakers from abroad and India who are working on this field, delivering the sessions during this FDP. And I'm definitely confident that all the participants will gain knowledge and benefit greatly from this FDP. Thank you once again. Welcome you all for this FDP on data science. Thank you.
Thank you, ma'am, for your insightful words. With this now, we now move forward with our first technical session of the FDP by Dr. Gayatri ma'am. It is an honor to introduce Dr. Gayatri Nagarajan ma'am, a distinguished expert in the field of data science, artificial intelligence, and machine learning. With a diverse career spanning across academia, research, consulting, and entrepreneurship, Dr. Gayatri has contributed extensively to the advancement of AI ML techniques and their applications in various industries. Currently based in Germany, Dr. Gayatri is an independent data science consultant assisting organizations in exploring datasets and deriving actionable insight to drive business growth. And she is the founder of Data Science Made Easy, a platform designed to bridge the gap between academics and industry in the AI ML domain. Her professional journey includes working as a mentor at Springboard and R&D engineer in Singapore and holding academic position as a professor and researcher in India. She holds a PhD in machine learning and has also contributed to several research papers, books, and guest lecture at academia institutions worldwide. In recognition of her excellence, Dr. Gayatri has received several prestigious awards, including the Best Researcher in Data Analytics at the International Research Leadership Award and the Young Woman Educator and Researcher Award by the National Foundation for Entrepreneurship Development. Dr. Gayatri's experience and knowledge make her valuable resource for anyone looking to deepen their understanding of data science and its real-world applications. We are excited to have Dr. Gayatri ma'am with us today, and we look forward to her insights on how data science, AI, ML are transforming industries and shaping the future. Dr. Gayatri ma'am, please take over. You can start your session.
Yeah, a very good morning to all the faculties here. Time is very precious, so I would like to start with my session. But before that, I would like to thank few members. Um, my first thanks goes to Gopalan Institute of Management, who is very eager and very interested in bringing up the quality in education, in organizing such activities, to the principal, and my special thanks to Dr. Manoj sir, who has been very ambitious and eager in incorporating the quality of education in his department, to the HOD of Computer Science and Engineering. And once again, my special thanks to to Professor Kavita, who has been coordinating and organizing it in a very nice way. She has been constantly following up with me for all the logistics and other things. I hope I'm visible. I'm sorry that I'm little not that bright because it's only 5:30 here, and you could expect the sunrise only around 8:30 here in Germany. So I'm sorry for that. So I hope we can jump into the session, and I hope I'm audible too.
Yes, ma'am.
Okay. So I'll share my screen. We can get into the session now. Please let me know once you're able to view my screen.
Not yet visible.
Yeah, I hope it's taking some time.
Yeah, now it is visible.
It is visible.
Yeah, we can
Uh,
see.
Thank you. So because I did my presentation with Canva, which is again an incorporating AI into it, so that you could understand well. Now PPT has almost died. It's almost dead now. Microsoft PowerPoint. So we use our AI for everything. Okay. So the topic given to me is data science. is Data Science in Education, Enhancing Academic and Research Curriculum. When I was given this topic, I was very eager and interested because uh, this is something which is very hard these days. And bridging the gap between academics and industry is not only spoken in India but also worldwide. So this is quite interesting topic, and I have to definitely congratulate Gopalan College of Management for organizing such important and essential topic at present. Okay. So I'm an independent data science consultant in Germany. A brief introduction have been given by about me by Swati. Thank you, Swati, for that. So today's contents. So let me give a broader overview for this FTP. This is because as this is my your first session in FTP, I'll give you a broader overview, and some of my colleagues and friends will be going in detail about specific topics. So today, according to the broader overview, as a larger perspective that we could see, I have listed four main contents. The first being data science, its introduction and the life cycle. So as data scientists, what are the steps that we need to follow, and what are all the steps that have to be followed in sequence, and come up with a perfect data science, giving a data science value to our business. And the next topic is data science as a curriculum. How are you going to incorporate data science into your academics in future? If you're planning to start your bachelor's exclusively as a data science branch, or you're already taking up as a value-added courses, or you're taking it as a paper or something. So how can you incorporate it successfully in your curriculum? What are the challenges related to it, and what are the possible solutions that you can do to overcome such challenges and to make the curriculum interesting both for the students and the faculties. And the third one is data science as a research area. I could see many academicians, and not only academicians, even corporate professionals who are interested in pursuing research in data science. So let me explore you some research, a broader perspective of some research areas where you would put your hands to work on them and publish very good research papers, very good patents, and you can contribute much towards research in this particular field. And finally, a case study that involves how a data science is used to enhance your business, to solve your business problem. A proper case study that I had worked on my own, that I'll explain you so that you will get a brief idea about how the theory is being implemented practically. Okay, so let's move into the content. Terminologies. You might have heard about data scientist, AI engineer, ML engineer, business analyst. So there may be confusions not only among the students but also among the faculties and corporate professionals who are not into this area as a working professional. So what is the difference between a data scientist and an AI engineer? So you might have seen in your in many job requirements that AI or ML engineer and data scientist, some saying it is a business analyst and some ML engineer, data engineer. So let me explain you what is the basic difference among these different types of branches. So basically, if you see all these topics come across or around across a particular circle, but there is a thread, there is a narrow gap among these professions or these topics, which you should understand perfectly and choose your particular area. Some people may be interested in AI, some may be in machine learning, some may be in data science, and some may be in business analytics. Unless and otherwise you understand this narrow gap very clearly, you won't be able to explore, put yourself into that particular field. So let me tell you that gap. See, AI, artificial intelligence is something which not only uses machine learning. Actually, machine learning is a discipline of artificial intelligence, but machine learning alone is not AI. You might have seen some smart devices, sensors. For example, I could go to my school to pick up my kid, and I can switch on my light at my home, switch off my light at my home. So this happens because of the smart devices. And any sugar patients or BP patients, there is a strip that are actually injected into their hand, which predicts the sugar level at each and every point. It helps them to see at what point of time the sugar is going up or sugar is going down. And every 14 days, they change the strips. So without having that insulin injector, a strip once for every 14 days, you could see the graph, how your sugar is going up and down. So this is all because of AI. So basically, artificial intelligence is to automate the human tasks. So you could see some robots taking up the load, carrying up the load in warehouses. So this is an example for artificial intelligence. So it is not that it requires machine learning to automate the tasks. You could see automated vehicles, autonomous vehicles, self-driven cars, which are all part of AI. So the person who is going to give you sessions on the last 2 days of FDP, he is more into AI. You can get more, much more detail from Dr. Rapith, one of my colleague who is a perfect AI engineer. So machine learning is a discipline of AI, whereas AI also include other disciplines such as robotics. So it is basically to automate the human tasks. So, coming to machine learning is a set of algorithms or set of techniques where a training data is used to learn. So, the machine actually learns by means of the data that is given to it, and then a testing data is given to it so that by means of its learning, it has gained some knowledge, and with that knowledge, it is predicting the value for that data. For example, you could see in your education sector that a particular student enrolled. So, what are all his most of the case studies that I would take will be more related to education, as this topic is closely related for the same. So a particular student enrolled, you could see his past histories. So how was his rank in his 10th standard or in his 12th standard? So how would he be able to perform? How is his background, his score in his entrance? So what grades can you expect? Can you predict from him? So that is machine learning. And you are hiring an employee, you want to check whether the employee will stay with you for a long time. This we call it as employee retention program. So whether he will stay with you for a long time, you can give some pre-trained data to the model. That is a data set of employees where they have worked. I mean, how far they have transferred jobs, how frequently they have done it, and all this are used to train your mission. I mean, the particular algorithm, maybe KNN or maybe Naybase or whatever the algorithm it is. Then you could come out with a prediction that this employee is more, say for example, 75% likely to stay with you for another 5 years. You could choose your principal or vice principal can choose, okay, he will be there at least for minimum of 5 years. Okay, we can recruit him. So it is there in each and every field, not only with respect to education, with respect to patient data in hospitals, the doctors' predictions, and many other sectors which we can give as examples. This is machine learning. And when it comes to business analyst, so business analyst is a person who see everything in a business perspective. So he may use machine learning, or again he may not use machine learning. He just explores the data and see how he can improve or enhance his business. That's what he does. Sometimes what happens is he explores the past 3 quarters of the sales. You see, okay, the first quarter we haven't done much. Okay, the second quarter is good. Okay, the third quarter, the sales has again dropped down. What may be the reason for it? So this is business analyst job. In case he wants to predict the sales for his fourth quarter, then he will end up using machine learning. So this is more into a business analyst job. He uses Power BI, Tableau, all these kinds of techniques to see how he can improve his business or what happened to his business in the past. How is the trend going? All these kinds of stuff. He may or may not use machine learning. And finally is our topic, data science. While AI is more to automate the human task, data science is the contrary of incorporating human expertise or human knowledge to derive insights from the data. Please understand the narrow gap very clearly. AI is mainly to automate the human tasks. That it targets to reduce the human intervention, whereas a data scientist has to use up human knowledge or expertise to derive insights from the data. For example, a data scientist may use machine learning or may not use machine learning. His task may get completed during the phase of exploratory data analysis itself. So, what happens is he collects the data, he wrangles the data, he pre-processes the data, he does some exploratory data analysis. At times, this is enough, but at times, according to the business requirements, it may not be enough and it may go for prediction. Only if it goes for prediction, he will be using machine learning. Otherwise, it is not required for him to use the machine learning. So, for example, where a human intervention or human expertise or knowledge is required is, for example, I'll tell you, you could see some data missing in your data sets. When the data scientist is going to pre-process the data, he would have noticed, why is this data missing? So, what is this basically? Say, for example, many persons are driving the vehicles, and the policeman is trying to test each and every driver for alcohol. He's going to test the drivers for alcohol, whether they have consumed it or not. See, some of the persons might be hesitating for the test. It may more likely because they are drunk. Otherwise, they would have come and they have tested. Okay, so here, if more data are missing for a particular person, you might think in that view. Maybe, yes, he might have consumed this alcohol. So, in that particular column, whether he has consumed alcohol or not, you couldn't directly put it as no, 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 no. Because if they are hesitating and if the data is missing, he's more likely to consume. So that is where your human intervention comes in. This is something that AI cannot do. It cannot think on its own. It is what you are programming. So it has its own use. It has its own applications, sensors, smart devices. You're controlling, say Alexa, say Siri, all these things. Whereas a data scientist role is especially different. He has to think to a particular extent. You're seeing a data. You're saying, for example, your own students database. You have a data set where the age is, for example, 104. Not feasible. Any a student of 104 is not feasible, right? So that is where your human intervention or human expertise is coming into play. So you could say that, okay, this is something wrong in this data. So this is what that AI cannot do, but a data scientist has to do. So data scientist may use machine learning if the task requires prediction, and he may not use. The same way, a business analyst may use machine learning if the task requires prediction, or he may not use, depending on his task. AI may use machine learning or it may not use. A very good example is chatbot. Chatbot is an AI, but it doesn't use machine learning. Okay. So machine learning is basically a discipline of AI, but it is not the only discipline of AI. And data scientists may or may not use machine learning to extract insights from the data. And business analyst may or may not use machine learning depending on his business requirements. I hope I'm clear in explaining the narrow gap among these different disciplines. So you may decide if you want to go for designing a smart device or sensors or wearable devices or robots, then become an AI engineer. So if you want to extract some insights from the data, a proper processing, how it works, and then you want to predict something, go for a data scientist. Or if you want to work more towards a particular business, a particular domain, or particular sector, then move towards business analytics. Okay, well, so you're clear with the terminologies now. Now, the next thing is dive deeper into data science. So we have the past, present, and we are going to see the past, present, and future of data science. So past, if you see the past, is it something that data science is new? Do you all think that the data science is new? or does it exist already? So any idea from audience? I want this to be a little interactive session. When did data science actually come? When do you think the data science came into existence? Any participants? Okay, well, okay. So data science is not something that you are hearing for the only for the past decade, but it doesn't mean that it exists only in this past decade. In this, I mean, in this last 10 years or so, it actually exists a long back, in even in 1880s. But without knowing that they are doing the data science job, they have been actually doing it. For example, my great grandfather, he was owning a business, so he has to decide the price of, say for example, the coconut, the rice, and all those things. So what did he do? He actually saw his the buying cost. So what was my buying cost last year, or the same month, at which price did I sell it? So what are all the price that other people in that area are selling, the other marketers in that area are selling? So accordingly, so depending on the weather conditions and all those things, he decides the price. So this is exactly what a data scientist does, or what a business analyst does. So what happened was they were more with statistics, those points. They just had a paper. Say for example, last month it was like this. So the other marketers are selling at this price. So let's fix this price for today as this. So this is what they have been doing. It is basically an analytics based on some factors. They are fixing the price of that particular item. This is a data analyst job. They used statistics, they used analytics, and what happened was they did with a small sheet of paper, because there was not a lot of data for them to analyze. They were working only with small amount of data. So it was not a requirement for them to use a computer, okay, maybe a calculator over the past 200 years or so. That's it. But at present, with the emergence of many technologies like big data, machine learning, and all other techniques, AI, the smart devices, it's all popping up like something. The data, every single second, the data is popping up like something. Just now, I received around 10 messages in my mobile. So many people might have given some Instagram comments, some Facebook comments. At a fraction of second, there was so much of data, millions and billions of data that has been transferred all over. So with the advent of these technologies playing a major role for data scientists, data science has become a very demanding and hot research topic, because the more and more the need for the data analytics, the more and more data scientists are becoming popular. And what is it? There is a need. We have to do analysis. There is no other way, because of the popping up of lot of data, which are to be turned into business insights. And what about the future? There is always a question about the future. Why are you asking me about the future? There is always a question. Because you might have heard some people saying that data science, it has become a fame. Is it going to survive? You could, in another 10 years, data science is not going to survive. Is it so? Definitely no. So just think, um, because of the data explosion, the data is going to add more and more. It is not going to become less. Anyways, it is definitely not going to become less. The more and more amount of data will be popping up. Even a third grade child is having mobile in his hand. He is generating a lot of data. So with the amount of data explosion that is happening, and with the automation process that is happening, the future of data scientists is not a question at all. There is more and more demand for data scientists. So basically, as long as the data exists, data scientists will also exist. And the data is going to exist and more in the future. So definitely there is a future for data science, great future. The only thing is that if you are doing it, you know what you have to do in data science, then You can bridge the gap very easily, and either as an academician taking it as a research topic, or as a corporate professional working as a data scientist, your career will be a very great success. Now, so let me dig into the step-by-step procedure as a data scientist. So what are all the steps? How do we tackle the data science problem? So what are all the steps that we need to follow? So basically, the first step a data scientist has to do is problem formulation. What is the problem actually? He has to understand the problem. And the next step is data wrangling. Data wrangling is the initial collection and initial collection of the data, making it ready for the next stage. And the next stage is exploratory data analysis, where you are trying to explore the main insights from the data by means of visualization. So are we able to get anything from this trend? Are we able to get anything from the past data? That is what is exploratory data analysis. And the next step is data pre-processing. What we do is working with the missing data or shaping the data, all these kinds of scaling the data, all these kinds of things come under data pre-processing. Once the data pre-processing is done, then we go for data modeling, where your machine learning plays a role. And data modeling uses machine learning technique. So sometimes with exploratory data analysis, it stops. And sometimes it has to go for data modeling depending on the business problem. And the final step is the documentation. Except documentation, all other steps I'll explain in detail, because documentation is something that doesn't require any explanation, and the document standards vary from companies to companies. Different companies give me different standards, and the documents have to be prepared according to them, which is quite easier and can be self-done. Now, coming to the problem statement. We always believe that a well-defined problem is half done. So rather than jumping into the problem directly without knowing what is your actual problem, definitely you can't come out with a conclusion, or definitely you can't come with a solution for the problem. You need to know what is the pain point in the business. So you have to understand the pain point. Say for example, um, last year I did a project for a resort. A resort manager has come and told me, because of the increase in certain things or increase in the maintenance cost, I had to increase the price of the tickets in my resort. Price of certain adult tickets and price of certain child tickets for some various activities, and I had to increase the room price, all those things. The resort do provide some activities like swimming, all those things. He told me, I'll be giving you the data. You have to analyze and come out with me with a solution. To what extent I can increase the price so that my customers will not be reduced. I will get the regular customers and the same amount of customers. At the same time, I can ensure that I'm not ending up in loss, and the same profit I have to maintain. I'm not asking for a greater profit also, at least. But if it is a bigger profit, it is good. If it's a huge profit, it's good for me. So I should get a good profit, and at the same time, I should not lose my customers, and at the same time, without reducing my production cost or something, I need to increase the ticket price also. So to what extent should I increase? That is what is question. That is what is business problem. So I got the data set. I just analyzed. So how does it work? So basically, you have to understand the point. What does he want actually? He wants to increase the ticket price. At the same time, he he is very sure that his customers should not be reduced. So to what extent it can be increased? If suppose for an activity the adult price is 14, ticket price is 14 euros, and for a child price is 7 euros. Say for example, I could increase this till 16 euros, and the child price to still for example 8 euros. So that for that activity they are ready to offer, and they will do that. So how do I approach that problem? So step by step we can do that. So I should first find out what are all the factors that are influencing the price, and which are all the factors that the customers are ready to compromise if the ticket prices move, or not ready to compromise even if the ticket prices move. So to what extent the factors are influencing. So what will happen if I increase this to this extent? What will happen to my result profit? So these are all some things that not only requires machine learning. Now you would understand in a broader perspective what a data scientist does. So he has to use his own expertise knowledge also to solve the business problem. So you have to understand the pain point of the problem first, and then write down the constraints and scopes for the problem. Constraints in the sense, say for example, ethical constraints, legal constraints. I don't have enough data scientists to do this job, the resources. I don't have enough CPU or GPU memory requirement to do this job. That is a constraint. Or all this or some constraints. And scope in the sense, what is the scope for that particular problem? Say for example, I need this kinds of data, I need this or data sets also. I may require more data from external sources also. So to what scope you can limit it. For example, this resort does not only exist in Germany, it also exists in US. So I need the location from that particular area also to compare. So he can't randomly increase the price. In case he wants to increase the price in Germany, is he ready to increase the price in US also? But the psychological behavior of people in Germany and people in US may differ, and people in India may also differ. See, for example, here, if they want to go for a resort or something, people generally see what are all the activities in the resort. So whether they have swimming, swimming will be of more interest for here people here. Whether they are having any other activities. But in India, if you see what we see when we see a resort, what are all the easiest things that we are getting? For example, the best, the preference that we give is for food. Is the food good there? Is it a homemade food? Is it cooked inside, or do we need to go to nearby restaurant? So the psychological behavior and the priorities of the people changes. So the factors that influence the price changes. To what extent it changes? Say, for example, 50% this factor is influencing. In other location, 60% this is influencing. So the scope is I need only this location data, or I need that location data for also to compare. So to what extent I need the data, that is the scope. That I have to write it down. Then the success criteria. How do you measure your success? So for this problem, for example, for this resort, I measure it by, so I am increasing the ticket price to this particular extent. So I have to see, I have to wait and see if I increase this to a particular extent, the demand for the resort is also, yes, there is a good demand for the resort and there is no loss of customers. And at the same time, he could maintain his cost also, and he could maintain his profit also. That would be his success criteria. And the next one is iterative. See, all these processes, you're understanding the pain point of the problem. What does the business says? What does he require actually? And you are noting down your constraints, your limitations, and you're noting down your scope, and you're noting down the success criteria to measure the success of you working as a data scientist, your work as a data scientist. And then these processes are iterative. See, for example, you're doing something, you're getting some other constraint. You have to go and add to that particular constraint statement. And then how to overcome that constraint. You have to think about getting a solution for the same. You will get another scope problem. So this is something that is iterative. You will get another metric for measuring the success. So this process is not something that okay, you understood the pain point. You have defined your success criteria. You have defined your constraints. You have defined in your scope. You're done. You can't remove your hand from your paper that you're done. You have to go back, iterate it, add and add, and it is an iterative process. And finally, you come out with a well-defined problem statement, something like I have to increase the ticket price of adults and children so that my profit is not affected, and at the same time, I'm not losing any customers. So, which combines all the points that you have noted down. So now I have a small question for the audience, for the faculties. Um, this is a problem statement. I need to improve the ranking of my university. Say, for example, your own college would be in would have some rank in NA or F or some other thing. You want to improve your ranking. So, could you please think what is the problem statement for it? What are all the objectives? What is the scope? What is the risk? And what is the success criteria? Anybody? So, depending on what I have told, could you think how could you improve the ranking of a university? How could you define the problem statement for it? Anybody willing? Not sure. Nobody is raising the hand. Yeah, Preeti ma'am.
I'm
Please.
just trying. I think for ranking, first we see the computers, how many computers. That's it.
Mm-hmm. How many competence? Yeah. Okay. Any other?
That's it, ma'am.
Okay, okay, no problem. So, anybody else would like to try? How do you define the problem statement for improving the ranking of your university?
Participants can unmute their mic and they can speak. They are
Yeah.
given access.
The more you participate and try to answer, the more you will get the knowledge.
Hello, ma'am.
Yeah, please, sir.
I think it depends on the placement of the students, student activities, and
Mm-hmm.
social activities also.
Mm-hmm. Great, great. Okay. Okay, let me continue. See, this is the problem that you're coming out. Say, for example, your own college is coming to me, giving me this problem. I have to improve the ranking of my university. What all, how can you help being a data scientist? This is your case study, a real case study. So first, I have to define my problem. What is your problem? You have to improve the rank of your university. Next is your scope. So what is the scope? So what are all the data that you want for it? And what are all the constraints in receiving, getting that data? And the third one is you have to define the risks. Are there any ethical or legal risks involved in your process, in your analysis process? And the fourth one is objective. What is your exact objective? And the fifth one is measuring your success criteria. So let's see what are all the things. So to define a problem statement for this, the problem will be to improve the QS ranking of your university. Objective is identify the factors contributing to ranking and develop a plan to work on them. This should be your objective. So this is basically how a data scientist think. So for example, you're having the data, you're having so your data should contain what are all the features. Say for example, one faculty had told me that improve the placement. Yes, that is one of the factor. And Preeti ma'am had told something that is one again fact, one more factor. So you do have lot of factors like awards received by faculties, alumni placement, then student admission, students intake, research citations by the faculties, research centers, number of patents, or the age of the institution itself being a factor. Say for example, students would like students prefer to go to an older institution, which is, say, for example, 50, 60 years old, rather than going for a new institution, which is just 5, 6 years old. Age of the institution itself being a factor. So you have to check how these factors are correlated with your ranking. Which are all the factors that are contributing positively, and which are all the factors that are contributing negatively, and to what extent are they contributing. Say, for example, the research publications of the faculties contribute to around 80% of the ranking. Positive correlation. The more the research works, the more, I mean, the lowest your rank is. I mean, it's 1 or 2, something like that. It's a good rank. And the age of the institution, not that great. Okay, it's contributing, but maybe just 10%. So these are the things. The placement, yes, of course, it's a major factor. It's contributing. So to what extent each and every factor is contributing, that is what you have to analyze. That is what is your objective. And how can you modify these factors in such a way that your rank is going to increase. We are going to see that as a case study here also. And scope. So what is the scope? So what data you need? Basically the university ranking data of the past year. So all the universities ranks over the past year. So what are all the ranks, which are all the universities in the top positions? So in each university, what is the alumni placement? What is the quality publications? How many? What is the student faculty ratio? So all these things. And next comes the risks. So how about the availability of the data? Can I get it from the right source? And is the data valid? Is the data standard? I have to think about all those things. And are there any ethical issues? Because the other universities should not come and complain to you that you have got my data. Are there any ethical issues? So, and then the success criteria. What will be my success criteria? I'm doing something. I'm trying to modify some citations. Okay, if I improve the citation score by this much, my ranking will be improved to this extent. So I'm devising a plan to your university. So increase this by this much, increase this by this much, and increase this by this much. So these are all the factors that you should target at to improve your ranking. After my suggestions, and after the effort from all your faculties and the management group to improve those particular, to concentrate on those particular factors and improve it, is your university getting the good rank, the expected rank? That is your success criteria. This is how basically a business problem works. It's not only related to university in education sector, but in all other different areas. For example, I took my resort problem. So what I did is, first, so to increase the ticket price. Second objective, I identified the factors that contributed. So there are some free food provisions given. So if I need to give free breakfast, so how much of ticket price can I increase? So how much will it cost for me? So that all I have to compute. So what are all the factors that, say, for example, I told you Germans, for German swimming is one important thing. So I could increase the swimming cost to some extent. So even if the cost is extended, Germans are interested in doing it, in paying $1 or $2 extra and do that. So I could increase that cost. Say, for example, in India, so increase the price of vada, still we go for vada. I hope I'm right. So increase that. So which are all the factors that are contributing to this extent, small, minimal price. So what is contributing more? What is contributing less? What will be negatively impacting? So all those are something that I have identified, and the scope, your data both in this location and in that location. And the risk is your data quality data. So is it having any missing field, or is it having any wrong information, or all those things. And then the success criteria, yes, very well, it was successfully implemented and he's running a very good business here, and both in US also. So this is how we work as a data scientist to improve the business, to or solve a particular problem statement. So you have to be clear with this problem statement. This is the first step in your data science life cycle. Only then you can start with the next step. So I see some people stepping directly into the data without understanding what are they trying to solve. That will not work for a data scientist. It requires human expertise and human knowledge. Now comes the data wrangling process. So data wrangling. This is the next step. After defining the problem statement, what is the next thing that you should do? You should be collecting all your data. For collection of data, there are so many resources, so many APIs, I mean application programming interfaces developed for it. And you know that there are different kinds of data. So structured, semi-structured, and unstructured, as rightly quoted by the principal of GCEM, there are different types of data now. For example, in your education, I could see here some interruption. It's okay. So in education sector itself, you will be having structured data for example, faculty data, students data, and unstructured data. For example, faculty notes. Faculty notes is an unstructured data. Student notes is an unstructured data, and semi-structured data. Say for example, 10 years back, you might not have had parent IDs, parent email IDs. But after 10 years, in the same format, you might have included parents' email IDs. You might have included the student's LinkedIn profile. In another 10 years, we might not know what other extra things, maybe a smart device number for each student would be there in his hand. So these are all semi-structured data. It will follow a structure, but a not perfect structure. You may add some factors, you may delete from some factors, something like that. So to combine data from all different sources, and you have to analyze your problem. So for that, there are a lot of APIs, and you can have the data in your CSV format, in your Excel format, in your HTML format, many things in Python that helps you to collect data from different sources and then combine together. So now your data collection process is done with all the different APIs. Even web scraping tool you could use to collect data if you want to do a sentiment analysis, positive or negative sentiment. Say, for example, the government is taking a decision. Uh, what to say? Okay, budget release. So you're approving it, you're against it. I mean, some particular topic, say for example, Center for Artificial Excellence. I could see a lot of comments. Yeah, educators, they are always supporting it. It is good. It is something that is necessary. So we, as the world is going towards AI, we have to invest a lot of thing in AI. Yes, agree. There are also negative sentiments. First, take care of people's basic needs, then you can invest in AI. There are also negative sentiments. So how much is positive, how much is negative? Use a web scraping tool, pull up the data, what are the comments that are given, and then you handle it. So that is the data collection method. Now you have to collect all the data, nothing but collection of all the data. And then comes the data cleaning process. So in data cleaning process, you have to identify the relevant attributes and remove the irrelevant features. For example, I'm having something like serial number. I don't require it. I don't require serial number to analyze whether the employee will be with me for another 5 years. I don't need my serial number, or I don't need a student's phone number for a business problem. Like for example, what will the student get a higher grade in the next semester? I'm just going to predict whether the student will get higher grade in the next semester. I don't need his phone number for it. So these irrelevant attributes I have to remove here. For that, again, a data scientist has to use his human knowledge and then merging the data. There exist Python APIs and there exist easy ways, even Gen AI. Right now, I'm not coding at all. Because of Gen AI, it has become very easy. So a good news for academicians is that not only academicians and corporate professionals, I could see many people be fear. I love coding, but still there is always a fear for some people to put their hands in coding. That's a very good news that Gen AI will do all the coding. Only thing is you have to apply your knowledge. What is the next step that you should do? You should tell Gen AI. So collect data from this source. Remove the attributes. So you have to find which is irrelevant. Remove the attributes, ID, phone number, email ID from this data set that you have to tell. GenAI will do the coding for you. And then it gives you the data set without those attributes. So please make use of all these advanced technologies and your human knowledge to become a perfect data scientist. And then merging the attributes. This, for example, I'm having selling price and cost price. I don't require those two fields. Instead, I can make it as a single field, say, for example, profit or loss. Negative if it is a loss, positive if it is a profit, and by how much. So I could merge the features, the relevant features. So that again, I have to use my own expertise knowledge. And format change, if there is any date format or something, I need to change that. So all that I can do. This is all comes under data wrangling process. You are basically preparing the data, and then any spelling errors. So there may be some spelling errors, some miscorrections, some things. So all this can be done on your own. It doesn't require any AI or it doesn't require any ML. So you're just here collecting the data, you're cleaning the data, and the next is your data validation. So in data validation, you're analyzing the source basically. Am I getting it from the right source? So you can't just pull the data from somewhere for a university ranking. You should check whether the source is reliable, whether the source is trustworthy, because you can't work on data which is not of quality and you end up with some prediction which is of no use. If the quality of the data, if the data itself is wrong, then there's no use for your prediction, because the prediction is not going to help solve your pain points, the problem statement. So that is, you have something that you have to check. Are you getting it from the right source? Is the source trustworthy? Is the source reliable? Say, for example, I could say in India, the government themselves have a particular site. I don't remember the site. Yes, there is a site. You could go and check. The health department, the tourism department, they themselves have given the data sets very clearly. They are all trustworthy sites. So you could get the data, you could do some research centers. Recently, I did one for the number of primary and secondary hospitals in India. So which areas are lacking the primary care facilities, all those things. So that kind of a trustworthy source need to be there. So you can't just pull up from somewhere and you can work on it. And then the quality of data need to be checked. So as I told, if there are, say, for example, 70% missing values in your data set, is there any worth of analyzing the data, deriving insights from them? Literally of no use. So check the quality of the data. At least to 30%, it's manageable. And in one or other field, if it is little high of missing data or something, it's still manageable. But the quality of the data is very important. With the poor quality data, you can't get good insights and it will be of no use to your business. So it's merely a waste of time. And then the standard of the data has to be checked in. There are few standards for few specific requirements. This is more into industry oriented, industry standards. And then the range of data. As I told you, for example, you could say something like age 250. So you know very well that the age cannot be 250 for somebody. He cannot survive. So, or the minimal and maximal range correct. So your student database, you are having something like 5. So what is this? The age of the student is 5. You could check there is something wrong in this data. So this is what all you have to check, and you have to work on the data wrangling process. First is data collection. You're collecting it from different heterogeneous resources and different types of data. And the next one is data cleaning. You're cleaning the data to derive or to remove the irrelevant attributes, merge if wherever required, format change wherever required. Say, for example, currencies. I get like this much US dollar, US dollar. Dollars is not required. Remove that, because with that string, you cannot convert it into numeric and you cannot work on that data set. So these are all some format change that you require, and some spelling errors which are quite obvious. And then validate the data. This is your data wrangling process. Now you could understand where human expertise or knowledge is needed for a data scientist, why it is needed and where it is needed. This should be your second step after the formulation of the problem clearly. And then comes exploratory data analysis. So this is the step I even insist my students, students who are in corporates also, that you have to concentrate more on, because you will be getting a lot of insights from exploratory data analysis, and at times it helps you to solve your business problem to 90%. 90% of your business problem can be solved merely by visualization. So what is exploratory data analysis? Now you have got your data set perfectly. You have all the required attributes. You have all of them in the correct format. You have a quality data. You have the correct range and everything. Now you're visualizing the data. So there are different libraries, different charts for visualizing the data. If you want to analyze a particular variable alone, you could use univariate analysis methods. Univariate is analyzing only a particular variable. Say, for example, box plot is one of the good visualization technique for univariate analysis. And so in box plot, you could see what is the mean, what is the interquartile range, what is the upper quartile range, what is the median, what is the mode. All these things will be visible very clearly. So you could tell it from the visualization. Okay, so this is my class, this is my 6th semester student. I'm doing a box plot for the maths subject, so exam results. So the mean for me is this, the mean of this class is this. And see, for example, the difference between the mean and the first quarter is more. So there are more students who got less than mean. There are very less students who got more than mean. There is one person who got the full marks. So all this can be analyzed with visualization. So you could easily predict, and most of your problems, almost I think 60% of the business who came to me got their problem solved in exploratory data and visualization itself. So that is univariate analysis. And bivariate is where you predict one variable based on other. So for example, a student's grade with his family background, you could predict it. So his family background is good. Emotionally, he is good. So is it affecting its student grade? Is there any relationship? You could check all the students with their family background and with their grades. Is there any positive correlation? The good the background is, the good the grade is. The poor the background is, the poor the grade is. It means a positive relationship. Whereas good background, negative grade. Poor background, good grades. Negative relationship exists. Your data points may be here and there, scattered. There's no relationship. So that attribute can be very well removed. I hope I'm clear. So that is bivariate analysis. And multivariate analysis, you analyze many different data, many different features for a single data is multivariate analysis. Say, for example, for your university ranking, your university rank will be your predictor variable, whereas your other variables, your university rank will be the predicted variable, whereas your other variables, predictor variables, will be your research citations, student faculty ratio,
5 minutes.
then your alumni employment, placement, everything. So that will be your multivariate analysis. There are many other techniques like heat maps. Heat map is one of the best example. So you will be having a very bright, big red color, which indicates that there is a positive correlation between these two factors. Say, for example, your research citation and your university rank. Great. You'll be having a very light yellow color, small dot in your heat map, which says that your age is not that correlated with your university ranking. So with this exploratory data analysis itself, you can very well come to major conclusions. It helps you to do a lot of conclusion. There are box plots, there are histograms, there are heat maps, there are correlation matrices, line graphs. So whatever you require, you have a explosion of all the libraries in your Python, and with the invention of more, the discovery of more libraries, more researchers works have contributed to excellent visualizations. There are also, recently I used one of the human interaction visualization, and it's very interactive. It's it's moving. It's like an animation. The visualization is like an animation. So that all is will really help you to to convert your data analytics knowledge to your business knowledge. Say, for example, you're having your management with you, your management is asking you, so how I don't want anything. I don't want any excuses. I just want to improve improve university ranking. How can we do that? So you have analyzed everything. You can explain it to the management in terms of business. So, sir, we need to improve the research citations. So, we need to improve the alumni placement. So, your visualization, you can always convert it into business terms because they can't understand a person without, this who is not into this data science, the business persons, they might not understand if you explain them in statistical language or in your data science language, and it is not required for them. They need only in your business terms. So that communication, see for example, this lady in the picture, she's explaining. So 60K, what is the average salary of a data scientist in Germany? So with all the graphs and with all the data, she could explain it very clearly. And next is with exploratory data analysis, you can go for feature importance. So which features are actually contributing, which features are not contributing. So that you can explore very clearly. As I said previously, so age of the institutions not contributing much, research citations contributing much. So those things you can analyze by visualization by your heat map, for example. And outlier would be easily predicted. So 1 or 2 points here and there, which are very far away from your normal data points, they are all accumulated in one particular place. Say, for example, between mean and the lower quarter, between mean and the upper quarter, then there is only one data point which is far away or which is far below. Then you have to see the point. Is it really a particular data or it is an outlier? So this can also be predicted in visualization. Once, unless and otherwise the data set is very big, you need not go even for outlier detection algorithms to predict all these things. And then finally comes the presentation. As I told you, communication and presentation skills is very essential for a data scientist. He or she has to explain everything in a business oriented concept for the person who is giving you the pain point, who is coming to you with the pain point. So I know I need to improve my university ranking. You have to explain him that what are all the steps that he could take to do that, and I need to improve the sales of this particular item in my restaurant. What can I do? So what are all the factors it is depending on? So you could do this, you could do that. That is how it works. So that presentation skills is also very important, and that is also part of exploratory data analysis. So we have analyzed that the first quarter the revenue is like this, the second quarter of a business has gone into this, and the third quarter is a little drop down. So fourth quarter, these are all the factors on which our business, our sales, our stock is, our shares is dependent on. So if we increase these things, our shares will definitely be going high. So that in that way, those are all the details that you would get from exploratory data analysis. Very major step and very important step. And here is the best example. So for university ranking, what I have derived, for example, age is not contributing as I told, whereas see the color of this particular bar chart correlation. So 91% is being contributed by academic reputation score, and 75% is contributed by employer reputation score, and 70% by employment outcomes score, that is your placement. And employer reputation is the companies which you are having tie-up with, how your students are performing there. And academic reputation is what's your um, um, how well you're as an academic, you have marketed yourself well. So what are all the programs that you have conducted, or what are all the internships you have conducted? So how well you have marketed yourself, that plays a major role. And what are all the things that you have achieved? Your students have got very the best project award here, there. So all these things. And you could see that faculty student ratio is just contributing to 35, 0.35. So this is how from exploratory data analysis itself, you can come to a conclusion. And on the left side, you could see the university average overall score distribution. So you could see that most of the universities in America are in the top link, whereas in India, you could see them in the yellow, and in Africa, you would hardly see just 1 or 2 universities that are in a very low rank. So these are all some predictions that you could do. This is for world university ranking, not for India. So this one, these are all some things. And when I see when a business person sees, he could also it's self-explainable. He could also understand things very clearly from these kinds of visualization. So this is the third step that you have to do. Remember, the first is problem formulation. The second is data wrangling. You're making the data, you're preparing the data for your exploratory data analysis. And the third one is this exploratory data analysis, which is basically visualization and trying to infer all the statistics and other details, the majority details from it. These are some libraries that will help for exploratory data analysis. So Tableau is a BI tool. It's mainly used for business analysts, Power BI and Tableau or used or data visualization tools that are mainly used by business analysts. And Seaborn, Plotly, Matplotlib are all in Python. They all exist in Python. They give very great visualizations. Plotly is very excellent. And ggplot2 is our visualization tool. Yeah, most people do not learn R, but R has its own advantage. It's very good in visualization. Even when compared to Python, R is excellent in visualization, especially for statistical details, doing for statistical details. So those are all some libraries that you could make note down for visualization. And the next comes the data pre-processing. This is the fourth stage in your as a data scientist. So here in pre-processing, I could see I want you to be a little happy with the visualization. And always I feel that visualization has a greater impact on the audience rather than your talk. So I tried my level to give you high impact visualizations so that you could understand things easily. And these are all built by AI, not by me. Thank God. And dimensionality reduction is the first step in data pre-processing, but before that is missing data. So you have to handle the missing data. So if the missing data is too much, you could discard the column, that particular column. If in a data set it is too much, then you cannot use the data set itself. But if in a particular column it is more than 50% or something, you could discard it better. But if it is like 30% or 25%, something like that, you could always impute them. Impute in the sense you could fill it with your mean or median or something like that. And then, so once you fill in the missing data, you overcome them. You fill in with whatever technique you feel comfortable with. Say, for example, mode, for example, median. For categorical data, you could fill it with mode. And for continuous data, you could fill it with mean or median. And there are several other imputations also. Even one of my research paper had done imputation based on modified KNN. So you could use other research works also to impute data in a much better way. After the missing data is done, come for dimensionality reduction if it is required. Dimensionality reduction and feature selection are two different processes. They are not the same, one and the same. So feature selection is identifying only the features, selecting only the features that are actually contributing and removing those features that are not contributing. You use some metrics like filtering metrics, for example, minimum redundancy and maximum relevancy attribute. That is one of the statistical metric that you use. So what does it mean is any attribute or any feature that is not redundant with other attributes, with other features. If it is redundant, any one you can take, not both, right? At the same time, it is more relevant to your predictor variable. So those features you can keep it. And based on correlation, based on many other filtering techniques, information gain, you can keep only certain features and discard the other features. So that is feature selection. This is quite obvious for datasets which have less features. I mean, not the observations, but the features, number of features. Usually in industries, we work with less number of features. Say, for example, even when I did a project for Lufthansa, I worked only with 26 or 27 features in it. And dimensionality reduction is the process that you use when your dataset is having many features. In my research, my dataset was having I have to work with gene data, genomic data. So gene 1, gene 2, gene 3, there were around 50,000 genes. And it is highly impossible for me to look into each and every data point of those 50,000 features and then analyze. So in those cases, we use dimensionality reduction technique. And there are many techniques like autoencoders, starting from PCA, which is the base. There are many different techniques like autoencoders, which deep learning, which actually reduces the dimension. It actually works based on projected vectors, um, principal component analysis, those concepts, those mathematical concepts, and it reduces the dimension to very few, PCA1, PCA2. You will be getting very few, say, for example, 50,000 feature data set has been reduced to 15 feature data set by means of dimensionality reduction. But the only problem with dimensionality reduction is inference. Inference is a bigger problem. You can't infer which one is more contributing unless and otherwise your exploratory data analysis is good. But that again, with high dimensional data, it is, there are a lot of research works that are being carried out, but still we can get only abstract details. There is no research work that gives you very clear details where the interpretation is very clear when working with high dimensional data. I'll take you through those gaps that you can fill in by means of your research work when you're doing with the when we are doing with the next topic. So that is dimensionality reduction. So what you're basically going to have only the features that are going to contribute to your predictor variable. And the next one is scaling of data. So this is very essential step because there may be one feature for which the value may range from, say, for example, your salary. The value may range in 5-digit or 6-digit numbers. And there may be some other features where the values will range in just 1-digit or 2-digit. So that is the small pot. So when you are doing some models such as linear regression, for example, the bigger values, the greater values, the larger numbers contribute more, whereas the smaller numbers contribute less when you are developing the model. But that should not happen. All the features, the contribution is different. In terms of, for example, your salary is contributing more or your age is contributing more, that is different for analysis. But when it is training the model itself, it gives more importance to the larger numbers because that affects it more. But it should not affect, it is biased. It will be a bias if it does. So you have to scale it in such a way that all the features are in the same range. So basically you're normalizing it. You're making it somewhere between 0, 1, or you're making it somewhere between 1 to 100. So that all features are in the same range or normalized. And then you're training the model. Then your model will identify which feature is contributing better. Not by means of the number of digits, but by means of the value it is giving it to the predictor variable. So that is where why you have to do scaling. And then comes the test train split. So this is again another a big topic. Actually, it's very less. The time is very less for me to cover more things because these are all broader areas. So I'll just give you a snap. So train test split is where you split your training and testing data. So I'm also a technical interview panel member in a few companies like Andon Technologies and all. So when I interview somebody for a data science position, I asked a question. So what is your percentage of train test split data? Randomly answered me, it should be 70-30. It is not correct. So you can't actually fix it as 60-40, 50-50, 70-30 or something. So it depends on your data set. It depends on your model. It depends on the processes that you are following. So a test train split is actually, why you are doing that split? You are actually doing it to test, to check how your testing data is, how well your model is working for the testing data. So you could use some techniques like cross-validation techniques, where you could take one set of data as test data and train on the remaining 9 sets, and then Take the second set of data as testing data and train on the remaining 9 sets. Take the third set of data as testing data and train on the remaining 9 sets. That is how your training testing split has to be tried with the different ways to ensure that your model works perfectly or yields a better accuracy. So this is then you're now splitting the data, because you can't train your model in all the data that you are having. If you're doing that, then your model will be overfit. And you can't train your model in a very less number of data. If you're doing that, your model will be underfit. So in order to ensure that you're having the right fit, you should neither train it with too much, nor train too much, nor train it with very less data. So you have to try with different splits, and not only by means of accuracy, you have to check your working of the model. There are a lot of other metrics by which we have to test. Okay, so now in data pre-processing, you have these 3 techniques, which are dimensionality reduction, unscaling, and test train split. So this is data pre-processing stage. Now you have your data for training pakka ready. This is where you're going to do data modeling. So remember, the first is problem formulation. The second is data wrangling. The third is exploratory data analysis. The fourth being data pre-processing. And now comes the data modeling. So this is where your machine learning model will come into play. So how does it work? Sometimes exploratory data model itself, with your exploratory data analysis itself, your business problem will be solved. Okay, say for example, they are giving you a business, like just analyze my sales over the last quarters. So that will end your problem with your exploratory data analysis itself. So you can submit your results as a data scientist, that in this quarter it is this much. So say for example, in first quarter it was high with about 50%. The second quarter it was less with about 25%. The third quarter it was more than the first quarter but less than it was more than the second quarter but less than the third quarter by this much percent. So all those you can give. So that you can get it from exploratory data analysis itself, you can stop it. But some cases you have to predict my sales for the next quarter. So in that case, you will go up for data modeling. And this is where your machine learning will come into picture. The first one is choice of the model. So when you're training your machine learning model, you have to first identify which model will best suit for my data set. Even now, when I interview for data scientist recruitment, so when I ask them which model do you choose, immediately they are answering random forest model. Because that, why do you choose that model? They are just replying me because it yields better accuracy. Not so. For different data sets, you have to use different models. There are some techniques, there are some logic behind which you have
full sports center application. ಸರ್ ಏನ್ ಹೇಳಿದಾರೆ, ನಮಗೆ ಮಾಡ್ತಾ ಇರೋದಲ್ವಲ್ಲ ಅದು, ಅದನ್ನ ಬೇರೆಯವ್ರಿಗೂ ಮಾಡ್ಬೋದು, ನಾವು ಒಂದು ಕ್ಲೈಂಟ್ ಅಷ್ಟೇ. ಸೊ ನಾವು ಯಾಕೆ ಅಲ್ಲಿ ಎಷ್ಟು 100% ಡೆವಲಪ್ಮೆಂಟ್ ಕಾಸ್ಟ್ ಕೊಡ್ಬೇಕು? ಹುಡುಗರು ಅದೆಲ್ಲ ಅರ್ಥ ಆಯ್ತು, ಅಟ್ಲೀಸ್ಟ್ 50% ಆದ್ರೂ ಕೊಡ್ತೀವಿ, 50% ಅವ್ರು ಮಾರ್ಲಿ, ಬೇರೆ ಅವ್ರಿಗೆ ಬೇಕಾದ್ರೆ ಮಾರ್ಲಿ ಅಂತ. ಇವರು ಹಿಂಗೆ ಹಂಗೆ.
Will you please ask them to mute? It would be better, the audience. Okay, thank you. So the choice of the model depends on several things like the data set, the business problem, how your data is. For example, if it is a classification and it is with a proper linear classification, where it is very obvious that this image is a dog, this image is a cat, this is a robot, this is a human. You could have seen in your interfaces, many interfaces, I'm not a robot. So in those cases, if it is very obvious, proper linear separation, you could use SVM classification model. In some cases, where you don't know whether it may yield a proper linear classification, then you could use some functions like kernel functions in SVM and many other techniques, Gaussian kernel and radial basis functions. So these are, you can modify the kernel functions and you can do your SVM. Some cases where you have to use non-parametric method, you don't want it to be a parameter kinds of things, and you don't have any pre-knowledge about the data, then you could go for KNN, because here you have just one parameter, the value of k, determining the value of k. And in other cases where you have a proper clear boundary for classification, if it is say for example, if it is a 6-leg, it is an insect. If it is a 2-leg, it comes to this category. Okay, so those kinds of classification, you may use decision trees. And in some cases where you don't have any idea about the data set, so you're clearly, it's a black box. In those cases, you could use neural networks. So neural networks are black box techniques. You don't know how it gets trained, but it gets trained. You can't interpret it perfectly because the hidden layer works in a way such that it converts the linear patterns to non-linear patterns. And this is one of the interview question that I myself asked the members. So what is the need for a hidden layer in neural network? It basically makes, if there is no hidden layer, your neural network can only classify linear data. It loses its capacity to do non-linear classification. So depending on how your data set is, depending on what parameters you know well, you have any knowledge about the distribution of the data set. So depending on all those, you have to choose your model. And for example, if you're going to work on image data, then convolutional neural networks are known to be better. If you're going to work on time series model, then autoencoders are known to be better. LSTM, recurrent neural networks, they are known to be better. So it depends on your task, depends on your data set, depends on your speed and time complexity too. Neural networks, deep learning networks, depending on the number of epochs, it requires a lot of training time. So that in some cases, say for example, a patient in ICU is receiving, you're recording the details of the patient in an ICU. In those cases, rather than getting the better accuracy, you have to get an efficient model such that it recognizes and it pops up, it sends an alarm immediately if something is going very down for that ICU patient. In those cases, more than a perfect accuracy, time is very important. So accordingly, you have to choose the model. So if for an ICU patient, you have to see, I have to get a better model such that my accuracy is 95%, 94%. Then you will be using your deep learning network with lot of epochs. You will get a better accuracy model. You can fine tune your parameters. You can get a better accuracy model. But before something happens, the patient is losing his consciousness or something, then the model gets trained. It gets, it sends a message. It sends an alarm or something, then something bad would happen for the patient. So in those cases, time is very important. In real-time data analysis or something, time is very important, more than your accuracy. So there should be a balance between your time and accuracy. So accordingly, you have to choose your model, depending on whether they're linear tasks, non-linear tasks, depending on the dimensionality. For huge dimension networks, it's always better to go for neural networks because they do apply dimensionality reduction techniques on their own at the back. And there is another way, choice of metrics. So it is not only accuracy that determines how well you have approached your data science problem. There are other metrics that are of quite important. For example, in a credit card fraudulent detection, for example. So if there is a, you can't say that accuracy is the right measure for it. So you have 4 things in your confusion matrix: true positive, true negative, false positive, and false negative. It means the case is positive and it is classified as positive. True negative is the case is negative and it is classified as negative. And false positive is the case is positive, the case is negative, but it is classified falsely as positive. And the other way is false negative. So in case, for example, in credit card fraudulent detection, rather than accuracy, sensitivity is very important. Sensitivity is, if there is a fraudulent case, it has to classify the fraudulent case correctly. Even if a non-fraudulent case has been classified as a fraudulent case, it is okay. It is still okay because you can block the call. The customer can call, I am the actual person. It's not a fraud. So you are checking the identity of the person. You are unblocking it. That is still fine. But A fraud case should not be classified as not fraudulent. So in those cases, true positive is very important in your as a metric rather than your accuracy. True positive is sensitivity. So there are some business cases where sensitivity plays a major role than your accuracy. Accuracy means both the classifications. True positive has been classified correctly, and false negative has been classified correctly. Everything has been classified perfectly. It's overall. But sensitivity is true. The range of the rate of true positive being classified correctly as positive. The same way, specificity, which is classification of negative correctly, is important in some cases. For example, say in healthcare data, you're testing a patient for a disease. If he has the disease, it is negative. If he's having the disease, he should be classified as being negative. He should not be classified as a person who is not having the disease. He should be classified correctly. So in those cases, identification of negative correctly is very important. So depending on the metrics, it changes. Your model should be aligned with the metrics. So for example, in credit card fraudulent, I said that true positive is very important. In that case, if my neural network is given true positive correctly, then I will go for neural network. Your decision tree might be giving accuracy correctly, but not true positive, but maybe a little lesser uh, correct percentage of true positive than your neural network. So in that case, I will go for neural network, not for decision tree. Though accuracy is more in decision tree, my rate of true positive is very important here in credit card formulation, fraudulent detection. So that will be of higher preference for me. So depending on the business problem, it should be a right model that has to be chosen in your machine learning, and the right metric, and the model should be selected according to how it performs for that particular metric. That is your where your machine learning and your data modeling comes into picture. So this will be your final step. And in the data modeling, once you have trained and test the model, you can evaluate and improve the model. Many people have asked me, how do you evaluate and improve the model? Yes, you can still do. You can evaluate using different models. It is not that you have to try only with one model. You can try with neural network, you can try with KNN. In clustering, you can try with hierarchical clustering, you can try with agglometrical clustering, you can try with any other deep clustering or any other ways. And then you can see which one is best depending on the metric, depending on the problem, depending on the data set, and then pick up the one which is performing better. And in that, you improve the model. How do you improve the model? By tuning the parameters. Say, for example, in random forest, I have generated 100 trees. I could tune it. For example, I could generate 200 and check it out how my output is. Okay, I could generate 150, check it out how my output is. So in SVM, I have used some kernel function. I would use some other kernel function and check it out. Some other kernel function and check it out. So finally, there will be one particular function, there will be one particular parameter for which it may yield better results. That is your fine tuning. That is your perfect model. Ensure that it is neither overfit nor underfit. And then you finalize the model, then deploy it to your environment, you're done. Yeah, finally, I deployed my model. So this is how a data scientist basically works. Starting from problem formulation, going through data wrangling process, which includes collection of data and data removing of irrelevant data, cleaning, which is removing of irrelevant attributes and all those things, checking the validation of data. Then comes with exploratory data analysis, where you're applying your visualization techniques, trying to predict what are the best that I can derive out of it. And then some problems do and data in exploratory analysis itself. And then comes the data pre-processing, where you work with the missing data, you do dimensionality reduction, you do feature selection process, you do scaling the data, and you split the test train model. And then comes the data modeling in case of prediction, choice of your model, machine learning model, choice of your metrics, and then fine tuning your parameters, then finally deploying the model. And you're giving the test data, the model is predicting, giving you the best result that it can. Say, for example, if you improve your research citation score to this much, if you improve your student faculty ratio to this much, if you improve your alumni employment to this much, there is 95% chance that you will get a university rank of this much. So that is your final model that you are going to arrive at. Okay. So I think before we go for because next will be more like getting into academic curriculum, your research and as a curriculum. So this was the main steps of a data scientist and we have concluded it. So next, before we proceed ahead to our next topic, then the next three will be quite easier. This is half done. I think it is high time for us to take 10 minutes break.
Yes,
so that
ma'am.
we all can move away, have a cup of coffee, come back and concentrate properly. So I'll just have my screen as it is. I'll just unmute and I'll switch off my video, turn my camera off. When shall we meet back, ma'am? In another 10 minutes exactly?
Ma'am, we can start from 11:35.
11:35. Okay, fine. Okay, ma'am, sure. I'll be back.
Okay, ma'am.
Please have your cup of coffee and thank you.
Thank you, ma'am.
Can we start back, ma'am?
Yes, ma'am.
Okay, thank you. I hope you had a nice sip of coffee.
Yes, ma'am.
Okay. Okay, so you know now what a data scientist does actually, how they help their data science knowledge in handling the business problem, and how they give it back to the business, how they help the business grow or enhance or even solve the pain point of the business by using their data science knowledge. You know the steps, what are expected to do. Now, skills required for a data scientist. So what are the skills that are basically required for a data scientist? You would have seen all the steps. Now you know what are the skills. It's not only the Python or computer programming that makes a data scientist. Statistics, the basic statistics. So in the courses that I am designing for corporate people, I first start with statistics only. So what is p-value? What is hypothesis? What is null hypothesis? What is alternate hypothesis? What is ANOVA? What is univariate analysis? What is multivariate analysis? So what is correlation? What is the difference between correlation and covariance? Unless you understand these concepts clearly in maths, it would be difficult for you to understand how the machine learning works, even how to understand how to convert the metrics, how to interpret from the metrics whether your model is the right model. It will be difficult if we don't understand the statistics. Even a 10th 11th statistics like mean, median, interquartile range is all very important for your data science job. And next is your computer science. Actually, we need to know the libraries. We need to know that these are the things. At present, I'll recommend both the corporate trainees and also the academicians that you need not put your hands on into coding, but a little bit of knowing what are all the libraries, what are all the plots that exist, and just go through a limelight of uh, the courses and Python would definitely help. You need not remember now. Now, unlike our previous days where we have to remember and we have to execute, we have to check the error. It has become very easy with the use of Gen AI. You're just typing what do you want to do. Gen AI is generating the code, just executing the code. You're getting the error message, unable to resolve it. Ask help with Gen AI, getting your error resolved, coming back, correcting it. Life has become much easier. And your error correction time, I had spent hours of time in error correction during my initial stages, but now Gen AI has made it quite easier such that in couple of minutes it's solving my error. So life has become easier, but you have to know how it works. So otherwise you can't use them. Then the machine learning algorithms, right from the traditional machine learning algorithm, even a small concept like back propagation, till your latest algorithm, even the natural language processing, even the deep seek AI, how it works. You can't understand the latest algorithms without understanding the traditional algorithms. The gap does not exist only in academia. Where academicians fear to put their hands into coding, there is a big gap in corporate, especially to address. The corporate professionals just learn the new technologies, they just want. So, see, nothing is simple in life. They just want to use it, they just want a job, they just want a lucrative job and lucrative salary without knowing the concepts. Blindly using it makes you stagnant at some point. You can't proceed further in your career. So when I interview people, I see them whether they are able to answer simple questions in traditional machine learning algorithms. Only then I go for concepts like LLM, transformers, and how do React works, all those things. So if this is not done, only with that you cannot fine tune your model. You don't know what you are actually doing. Blindly, you're just going in a jungle without knowing where you're going. If it hits, good. If it doesn't hit, gone back. But go with a strategy so that you could hit whatever you want to. So please learn machine learning right from the basic traditional model till you're advanced. You have to know you're advanced, but right from the traditional model, do it properly, even if it takes time. Just half an hour of time per day is sufficient to learn slight difference between why a sigmoidal function is used for logistic regression. People can't answer such questions. That's really disheartening. And then data scientist requires more communication and presentation skills. You have to convert your data science language to a business language when you're explaining to a network of business professionals. So you have to get them, make them understand what the visualization says in terms of business. So you could have seen that exploratory data analysis is mainly concerned with communication and presentation. And then comes with data visualization techniques. You should be knowing to interpret from the visualization. You should do a lot of visualizations, how to interpret them, and all these things. And then the domain expertise. So for what business problem you are doing, unless you don't know how a resort works, unless you don't know psychological behavior of people at different locations, what do they expect from different resorts at different places, different nationalities, you can't know how to approach the problem. Unless you know how education sector works, you can't approach a problem as a data scientist. Though not a deeper knowledge, you need not be a professor, but at least that how it works, how the academia works. Discuss with the respective stakeholders, professors, understand how they do it manually, what they want to do. Discuss if you're going to work for, if you're going to take up a research work in your, for example, a small hospital. Discuss with the doctors how they do it manually, what they want to do. As a data scientist, what they expect you to come out with, what is the pain point of the problem. So have a broader knowledge on the domain, like how it works. Not a very deep insight knowledge, just a broader knowledge will help you understand the business problem and solve the business problem as a data scientist. So these are all the skill sets that are required for a data scientist. So now coming to our topic, how you are going to incorporate this in academia as a professor, so that the data scientist going out from your college is having all the skill sets perfectly, and he is going to save your name, show your name in the place where he is going to work. So you have to ensure that your syllabus is having all these necessary skill sets, or your student is being trained in all these necessary skill sets to become a proper data scientist. There are so many data scientists that do exist in industry. They are in top companies also, but still there are few who do not understand the basic concepts, because of which they are unable to switch over their positions. They are just sitting in a comfort zone, but we never know when that comfort zone will become discomfort. So please learn it in a proper way so that you can always even sit at home and work. Okay. So now, what are the challenges and what are the possible solutions? Incorporating data science in academic curriculum. Tomorrow, your university, there are so many faculties here, or there are also many corporate professionals here. Tomorrow, you want to start an online course, or your own college is going to start bachelor's in data science, or you are having data science, going to give data science as a value-added courses, even for mechanical engineers and civil engineers and electrical engineers who are interested in it, or anything. You want to teach it as a course. Number one, the foremost challenge is lack of awareness. Many people do not know what a data scientist does. Few students do not know what is the difference between data science and AI. Few students do not know what is an ML engineer and BI people does. What is the demand in the market for data science? There are always people who say that data science is going to go off in another 10 years. First programming language came, C came, C++ came, C hash came, .NET came, Java came, Python came. So after some time, new things are going to develop. Yes, new things will develop, but you have to update yourself. It doesn't mean that the job is going to evade. As I told you, as long as data exists, data scientist exists. There is always a demand. Salary, I would say that Germany is one of the place where one example where data scientist is getting an average salary of 120K per year, the best salary. And future of data scientists. What is the future? As I told you, many people are in a fear that so many are doing courses. So how many are going to get placed properly? See, just think a restaurant is there in a new corner of a place, but it is of quality. So last vacation when I came, there is something called Rameswaram Cafe in Bangalore. People had told me it's very good. So, but there is no proper parking facility there. You have to do valet parking and stuff. You have to go. It's a very rush area. Also, people because of traffic they don't want to go much also there. Okay, it's well. I wanted to try. I wanted to explore. So we went as a family. So going us okay. It took time. I went only from Whitefield. It took some time, but the order was served in just a minute of time. I was so shocked and surprising. What a business idea he has. So many people, so many orders, touch screens. So innovation. Where there is quality, there will be people. And whenever I crossed that place, I could see there is a lot of crowd. I think it should be the same now because I just went 4 5 months back. So where there is quality, there is things always exist. So if you are a good quality data scientist, you can always survive in the market. As an independent data scientist, I'm able to get lot and lot of projects which I sometimes say no because I do not have time to pursue. So you have quality, you have people attracted towards you, whether it's a restaurant or whether it's a job. That is how it works. So people are not aware about how the market is. So for that, how to overcome this challenge? Conduct some school level awareness programs. For example, your own management, Gopalan Institute of Management, have their school, I think. So there are other schools in Bangalore, like Whitefield Global School, Delhi Public School, National Public School. There are so many schools, even government schools you can pick up. Nothing wrong in it. So please go as faculties, take a session, just discuss with the principal. There may be students in 11th and 12th standards who want to pursue their career in data science but do not know what as data scientists do, how to approach, how to get into the career, what should they do to pursue bachelor's. So they do not have any awareness about a broader overview of what that job is. So those kinds of awareness programs will definitely help you get admissions. So approach the schools, conduct some awareness program, a small 1 hour session per month. You can pick up one school, do a 1 hour session, conduct an awareness program. It will improve your admissions and it will give more knowledge to the students too, that what data science is, and will help those who want to pursue their career in this. It is an attraction. It is imparting them the awareness. And integrated curriculum in higher education. You can also give it as a course in high school level programs, higher secondary level, like 11th and 12th, small, like weekly one class or something. They can integrate as a curriculum. Small data science topics like mean, median, mode, the statistics, and small things can be done to make them to know to make it interesting for them to get a what you say a taste of what data science is, so that students who want to enter the field, they'll be highly ambitious, they'll get a broader knowledge, they'll get a limelight, and that will help you overcome this challenge of lack of awareness. Very clearly, your high level students should be targeted because they are your entry point. And secondly, course plan. So I could see many universities even approaching me for a proper course plan. Please review this course plan if it is okay. There is no specific course plan for data science in any particular university. See, this is how it has to be taught. This. That there is no proper teaching principle. Say, for example, electrical engineering is something that exists over the past 70 years. There are the papers, the syllabus are all devised. Computer engineering exists over the past 25 years very well. The papers, the syllabus are all pakka devised, but that is not the case in terms of data science. So there is no proper formulation of teaching principles. So what is happening is mostly it is taught in isolation, but it should not be done like this. It is an interdisciplinary field. You might have seen what a data scientist does. He should know presentation and communication. He should have presentation and communication skills. He should be having good mathematical background, a good data interpretation and statistical knowledge, and he or she should be having some kind of domain knowledge also. So data science is not something that should be taught in isolation, that should be taught separately as this paper, okay, Python as a paper, R as a paper. It should be taught as a whole. It should be a holistic approach to cover, to ensure that different skills are incorporated into the student. And so the proper, comprehensive and holistic curriculum has to be given to the students to enhance their education and training. And then regular upskilling and dedicated courses have. Okay, thank you. Please mute yourselves. Request to kindly, there's some disturbance.
Yes, ma'am, I'm checking.
Yeah. Thank you. Okay. So, data science is should be taught as a holistic and comprehensive curriculum, and not to be taught in isolation. And dedicated courses and regular upskilling has to be given. Today, yes, there is something called Gen AI. Tomorrow, there may be something else. Day after tomorrow, there may be something else. Yes, it comes. DeepSeek AI is coming. LLM is coming. First, natural language process came, then LLM came, React came. It just came more and more. Today it is ending in DeepSeek AI. Tomorrow something else will definitely come. So you have to regularly upskill. The syllabus should be regularly upskilled. At the same time, the basics should be taught well. The basics should be the paper, whereas the new technologies or the latest technologies should be given as an upskilling course or dedicated course for the students in their pre-final and final years, so that they are thorough with the basics and they could cope up with it. Please don't jump directly into your latest technology without understanding the basics well. And then comes the then that what will happen if you do that is you could survive for some time in industry, but you cannot grow in your career if you are not good with the basic concepts. And what will happen in research is, again, academicians, they have to do research without knowing the traditional things, how they work, because you have to get into the traditional, you have to get deep into research, you have to understand the problem well, and then you have to create your own technique for improvement or as a new technique to solve something. So in that case, you should have a deep understanding of the basic concepts. So regularly update, have incorporate dedicated courses for pre-final and final year students, but only after them being strong in their basics. And then the next one is collaboration with global institutions. This is of major help. You could have some collaboration with not only very big global institutions. You can have some institutions, not very high level also. They will be definitely ready to hire. You can have give some one internship abroad, one semester abroad. So some kinds of this kinds of tie-ups will definitely help. Later, when your ranking improves, you could seek a better university for tie-up. So these are just small processes that you could incorporate in your university when you're teaching data science as a curriculum. So have one semester abroad, advertise like one semester abroad, and have tie-up with global institution. The student will get enough knowledge. He will come and tell you so how that institution works, how they are incorporating it as a curriculum, So that feedback will help you improve the quality of your course. So have tie up with global institutions if possible. And then not only in countries like Europe, in US, even in Asia, there are good universities available. You could look for some one internship abroad, and students from those universities can come to your university for doing one semester abroad. So these kinds of things will definitely help you devise a proper course plan. So remember that it is not to be taught in isolation. It is an interdisciplinary skill where presentation, communication skills, where statistical knowledge, all these things have to be incorporated along with the programming language. And regular upskilling also has to be done, taken care in your course plan. And then some people have, some students, even my past students have asked me, ma'am, there are so many courses, online courses on data science. Why should we go for a proper degree program? So please make them understand that there is a lot of difference between online course and degree program. So I did a lot of online courses to update myself in data science and still do that because I didn't have a degree program when I was pursuing my bachelor's or master's. It was not there. So to upskill myself, I have to do online courses. Whereas now they have it separately as a degree program. If you want to master that, better take it. If you are sure that you are going to pursue that career as a data scientist, better take that degree program. There is a lot of difference between online course and degree program because professional degrees speak well in your profile. If your profile is having bachelor's in data science, that will be given more value than a profile who has done online courses in data science. See, these online courses are for those who are working already and how to upskill themselves. They do not have enough time to pursue bachelor's or pursue master course, and their finance is very important for them. So they have to work in order to upskill themselves, in order to enhance their knowledge. These online courses have come up, but the quality definitely differs when you are giving it as a degree program or value added course in university. So please make them understand that a degree program is a proper supervised learning. You have a professor under whom you are going to do your project, you are going to do your internship, who will be regularly supervising you. You have checkpoints, you have your exams, you will be they'll be reviewing your results, everything. So a supervised learning differs from online degree courses. In online degree courses or in online courses, you just have a capstone project. You just finish the capstone project, you're done, you will be getting your certification. There are many degree courses available outside also. And I, being a data science mentor, have also worked with some online programs, courses. They are more suited for corporate professionals and for those who are highly self-motivated to drive them. See, only 30% can be got from obtained from online source, online courses. The remaining 70 you have to put in your effort to understand. But that is not the case for degree program. They are given a proper supervised learning so that it is taken step by step, handhold. You're shown, you're guided the direction in a very right way. So that will help you brand your degree programs or value added courses well. Quality of teaching speaks in degree programs. And projects, you will be having so many projects, almost one project per paper in your data science when you are doing it as a bachelor's or value added courses in your university. So that will help you. Even I have seen some people in corporate who quit that job, go back, sit in the university, do the program bachelor's or the courses in data science. So MBA, even MBA in data science is there. So they do that for 1 year or 2 year. The company is giving sabbatical leave, sit there, study properly as a full time, and then go back and continue the work. Nothing is like doing a full time course. And then holistic approach you will get if you're doing it in a university in an as a degree program or also or as a value added course. So there is a lot of difference between online course and degree program. Online courses are good for corporate professionals who are self motivated, who can handle things on their own most of the time. But when you need some guidance or proper support when you're stuck, it is always better and immediately it's always better, and nothing is like full-time degree programs which speaks in your profile. So this is the challenge and this is the possible solution to overcome it. And next is the practical exposure. See, I told you that domain knowledge is very, very important for a data scientist. So how do you get the domain knowledge? How do your students get the domain knowledge if you're starting it as a bachelor's? Only by means of projects and internships. Have an internship in your fifth semester. Have an internship in your second semester. Do an internship in your not in second semester, sixth semester, fifth semester, seventh semester. Try to do the internships in pre-final and the final year of their course. So the more the internship you do, or even summer internships, I have seen a few posts even day before yesterday or yesterday that IIT and IIMs are also giving internships in AI and data science. Quite interesting, and it's more welcoming in India. So enroll for summer internships during summer holidays. Ask them to do it mandatory or do it encourage them to do it optional. So these internships, what it does is when they are doing a project for an education sector, they will understand, they will get the domain knowledge in education. So when they are doing a project for a health sector, they will get that knowledge. When they are doing it for a restaurant, they will get that domain knowledge. So help them do many internships, encourage them do many internships and projects. Let them do it well or let them even fail in some things. Doesn't matter. There is a story behind a failure also. So unless you step in, they will not understand. If you hesitate to step in itself, then you will never understand. There is a story behind a success, there is a story behind a failure. But if you don't step in, there is never a story. So encourage them, do more internships, do more projects, which will help them get the domain knowledge and skill set that is required for a data scientist. And then introduce hybrid learning models. So these are some things that I have seen in countries like Germany. If you see, you have a company sponsoring for study. So what do they do is after your 12th standard with the grade, a company will be sponsoring. So 3 months they have to go for university, and 3 months they have to work as an intern in their company. Next 3 months go for university. All the 5 days sit in the university, have classes from 8 to 4, write your exam, come back. Next 3 months you have to have your practical experience of the same. This is how it works. Just have a tie up with some small companies, even to have some hybrid learning models, or 3 days of university and 2 days of work. Okay. With a stipendum will also help, or without a stipendum will also be of use for students because they are getting the practical exposure. As long as in the industry they are giving a small, for them also it is useful, for academicians also it will be useful. So in both the ways, the student is getting a quality education. So he doesn't want a stipend in bachelor's itself. He may be financially capable to support himself. So the companies can hire them without a stipend also. And if they are performing well, they can hire them as an intern. For the companies also, it is good because their cost is reduced when they are hiring a student, when they are taking the student as an intern. For the colleges also, it is good because the student is given practical exposure. So please encourage such hybrid learning models when you're designing a curriculum. And there should be more collaboration between academics and industries. So the industry partners or the industry professionals can be hired as a professor of practice or what you call them as adjunct faculty or ad hoc faculty. Now in India, there are all these terms, and slowly all these are getting developed with the advancement of technology. Um, we can connect everywhere, and even industries are encouraging their professionals to contribute to academia. So please have more collaboration between academia and industry. What academicians do, industry professionals cannot do, and what industry professionals can do, academicians cannot do. So the students get make it a combination of both if you hire adjunct faculties too. So the project based learning. So it should be a complete project based learning. Data science should be a complete project based learning. You cannot make it as a proper theory paper. 50% can be theory, but 50% should be based on projects. Their results should be based on how well they had performed in the project, a real case business scenario, how they had helped it to get result. So that is how your course plan or degree program should be designed. for a data science, so that when they are coming out, it may be difficult to incorporate, especially in our country, because we are used to the traditional system. It may not be so warming initially, but when they come out as a data scientist, they themselves will realize that they have gained enough skill set, and slowly, in a slow pace, this will definitely be encouraged and welcomed in a larger scale, and you will be an example for bringing up such a good education system. So it will be of great help. You can produce good data scientists if there is a combination of industry and academia devised combined course plan and combined exposure. And there is one more challenge when it comes to data science. Lot of tools coming in, lot of techniques coming in. Where should I start? Where should I end? Seems like I should learn and learn and learn. Yes, you have to learn. Whatever it is, you have to learn. You're a professor, you have to learn. You're a doctor, you have to learn. You're a doctor, you have to learn. If you want to survive in the environment with the advent of new technologies and techniques, you have to learn. And when it comes to data science, the learning curve is not even gradual, it is steep. Yes, you have to learn more and more. And every day, at least half an hour, you have to learn. There are enough learning materials that help you. Lot of online resources, lot of blogs, lot of posts, lot of books, a lot of online sources. So it should be a continuous learning. It may not be more, it may be very less, even 15 times per day should be fine, but it should be a continuous learning if you want to survive. And it is not only this profession, it is required in all the profession, because every day something new is happening, something new is developed. There is a craze for invention, craze for discovery. There is the competition has become heavier, such that you're coming out with at times I have even questioned myself, is this automation really required? You're sitting, you're using Siri or Alexa, play this song. Is this really required? Not required at all. You can type in and play the song, or you can go and check and play the song. So some inventions are really not required, but why they have come and why they have stepped in? Because of competition. I do this, and we are used to it, and we cannot go back from it. If you ask me now, rather than typing, I'll say this, it will play the song for me. That is what made our life easier. So this desire, this greediness has become a competition, a financial competition among the markets. You come up with new solution, I'll come up with new solution. 2 years back, a startup came for data science, and now he holds a very big share value in the market. That is because of his inventions, his discoveries. If you go back and see, his inventions and discoveries are not really solving any business problem. It is something new, but it is something new, and people are crazy over that new. So what is happening? People are used to that. People want it, so it is coming in the market. You're not, see, a normal cell phone was much more essential for us. Okay, it came out from landline. It came out, then it came out. Now iPhone 14, iPhone Pro, iPhone 15, etc., etc. And Android also, it is coming and coming with newer versions, incorporating. If you go back, if you think a little bit, you might not need all the features. It is not always necessary, and it is not solving any deep business problems. See, some technique is coming such that even blind people's mental thoughts, or sorry, dumb people's mental thoughts are being predicted, and they are said what they are thinking or something. That is something that is encouraging. It is solving a business problem. They cannot speak out. Instead of writing, you have developed some device such that you are able to understand them. That is solving a business problem. But if you see some things that are not actually solving, but because of the competition they have come in. So the same way, the more the competition, the more you have to adapt yourself. It is survival of the fittest, as simple as Darwin's theory. So it's a steep learning curve, but do learn. It's an enjoyment. Take it as an enjoyment, just 15 or 20 minutes, whatever it is possible. As long as you know the basics, the other learning will be as simple as it is. Just proceed and go and go on. That's it. So design it in such a way that it is a holistic industry exposure. And the last but very important challenge that our academia is facing is the lack of skilled and experienced faculty pool. This is because proper training of faculties have to be done. Being in academia, we are occupied with our classes, administrative tasks. It doesn't mean there is a problem with the faculty. It doesn't mean there is a problem with the management. It means we can devise some plan such that training is also given for the faculties. Allocate some time for that training, for upskilling themselves, to enable them gain more knowledge. And you can also hire experts from industries for teaching it as a value added course, or teaching it as a bachelor's program also. So one expert, so the expert will coordinate with the faculty. So the basic theoretical background or something can be given by them. They can coordinate with the faculty how we can devise the plan. So the full-time faculty and the expert from industry can coordinate and deliver the course together, which will be of great use for the students. And attract quality teachers by giving them flexibility, remuneration, good packages. So attract them, try to attract them so that you have experienced faculties and skilled faculties. Please upgrade them, let them. There are so many professors who are attending, maybe more interested in diving deep into the data science. They want to understand, they want to explore, they want to take a data set, they want to do something, they want to find out. Give them the proper training, they will definitely do it. Allocate some time. And the faculties also should uh, put some extra effort and extra time to do the learning. It's not that you will work only for 8 to 5 and then you have to learn. Go back, sit at home, do your work, balance things, and then learn when you get time, self study. So tie up for faculty training and industry and institutions. And sabbatical, faculty can be sent for away for 6 months to some other countries as a sabbatical time period where he learns things and then come back. So that can be done, a 6 month of sabbatical to some industry or some other global university, by taking a bond from him that he'll come back and work for another 2 years with him. And if he is planning to leave, he will pass on the knowledge to some other faculty. These kinds of things will not only improve the faculty's efficiency and help them deliver a quality education to the students, but also help the institution gain its name by having good faculty pool. Now comes the data science as a research area. So this is for researchers especially who want to do a lot of papers, patents, and who want to work, contribute more towards research. The first one is data wrangling. So as I told you, the data wrangling step is like structured and semi-structured data. The heterogeneous data has to be combined together. They have to be merged together. They have to be collected together from different sources. There are a lot of APIs, there are a lot of web scraping tools available, but still there is a scope for research in this area. Researchers may please note down the points. I am just giving a thread, a narrow gap, which you can go read papers on that particular topic, enhance your knowledge, then implement your own um, way of handling the solution. Find out the problem and then handle the solution. So data wrangling, data collection process from heterogeneous data sources is one main area where you can analyze what is the state of what technique and how you can improve them, what is the problem and how you can solve them. And there is a need for virtual data integration now. So virtual data integration means, so you collect data from different sources, right? They exist physically in cloud or something. But in case of virtual data integration, they do not exist physically. Uh, they are not in your system. They are there in some other places, but you are accessing them. You're building the model in them. They are not brought into your system because the data may be huge to brought into your local system or something. You're accessing it from cloud, you're accessing it from somewhere. So that kind of virtual data integration techniques are more essential now. They do exist, but there exist gaps in these technologies. So any researchers who are interested in developing any new technique for virtual data integration or solve any existing problem with some existing state of art technology, most welcome to take this as another research area. Semantics, ontology is another research problem to work with. So ontology is especially meaning of something. Say, for example, I say EVS. EVS means environmental science when it comes to students. But EVS means electronic voting system when it comes to electoral election commission. So the same abbreviation, it can fetch variable. It will actually alter the meaning of it according to the domain. See, that's what. In case of electronic voting system, if it takes it as an environmental science, it will become a problem. In case of environmental science, if it takes it as an electronic voting system, it will be a problem. This is just an example. There are so many abbreviations that have different expansions in different domains. So, how to make the system understand that this is this particular domain and this means this in this domain. So developing an oncology for it so that your tool can automate and identify it clearly, properly is another research area where you can concentrate on. And data privacy and data compression algorithms. There is a high need for it. And data compression algorithms, especially, they do exist in many domains such as health data, especially when, as I said in example, the genomic data, which has a lot of features, compressing it may lead to loss of information at times. So how to avoid that? You can come out with some new algorithms or come out with some enhancement in your existing algorithms such that your data is also compressed but without any big loss of information. Maybe you can try reducing the objective function of loss and then you can come out with your own research methodology. And then data privacy. Data privacy is again another issue for which you can have your security based algorithms to ensure that data privacy is taken care of. So these are some research areas in data wrangling. I'm not going into deeper. I'm leaving it to the researchers to dig deeper into it based on your area of interest. There are other areas in data wrangling, which includes real-time data handling and latency. As I told you, for a patient in ICU, latency is something that cannot be tolerated. The data has to be processed immediately in real time. The streams of data get in and get in, it has to be processed in real time. So such things can be new algorithms can be developed or computational complexity of some algorithms can be reduced, like neural networks, the number of epochs can be reduced but the same accuracy can be obtained. So think about how can it be done, how can the latency be avoided, at least how can we minimize that particular latency, how can we handle the real-time data very fastly, the streaming data very fastly. So that is one research area. And data fusion approaches, combination of semi-structured, structured, and unstructured data from different heterogeneous data sources. So your sensor is generating. So say for example, a patient, a BP patient or a heart patient is going for a walking. He is having some issue. Immediately his sensor is sensing it. His sensor has to fuse with his son's mobile, then his mobile should pop up, your dad is in that particular location, GPS will be alerted, so he is unconscious, go immediately. So this kinds of fusion of automated systems, this is basically into AI. So how there do exist some fusion approaches, but still there are a lot of scope to improve these techniques to avoid the lagging of time, to make it more faster, more quicker, more better way to respond. So all these things can be considered as a research area. And temporal and spatial data handling is another thing. Say for example, temporal data is something like stock is a temporal data. So 1 month back my stock rates was this and now it is this, and in 1 week back it is this, at what will be there later. So for the temporal data handling, there do exist some networks like LSTM, long short-term memory, recurrent networks, autoencoders, all these things. But still there is a scope for handling temporal data in a better way. And spatial data handling concerns to geographical locations. The same data, as I told you, the same data set works in a different way in different regions, depending on the geographical locations, the priorities. So how do you combine data? So for example, even the resort problem, US it will be different, Germany it will be different, India will be different. But the same data sets, I mean, of course, it depends on different geographical locations. how can we handle them together as a whole with slight difference in implementing. So all those spatial data handling can also be taken care of. And when it comes to exploratory data analysis, as I had said you when I was explaining this step itself, visualization of high dimensional data is a big problem. When it comes to high dimension, visualizing has become a real problem because interpreting them has become really difficult. The more and more dimensions it is, interpretation of them has become very difficult. I mean, only very few could be visualized. And we don't know exactly what does PCA1 mean, what does PCA2 mean, which are all the features that it represents. So some algorithms or some techniques can be developed to make the interpretation very good. And some interpretation methods to connect this visual interface with statistical theories. So recently I had read a paper that was about smooth technique, so oversampling. So how can you handle imbalanced data set by doing oversampling? So we do oversampling, smooth technique. But that was the only paper where I could see some theoretical statistical theories connecting the smooth handling. So smooth generated data and the normal data before smooth. What was the class distribution there? What was the class distribution here? Is there any statistical difference after oversampling? So how are they affected statistically? So such theoretical papers are most welcome and they can be published in very high impact journals. So any researchers interested can do in the field of visual interface, exploratory data analysis to connect it with some statistical theories. And then subspace clustering methods. When the data points are too much, you have to do subspace clustering. Separate them, divide them, aggregate them together. How can they be made together? So such clustering methods are a need as long as the data is going to explode. More such clustering methods are required. And as I told you, interactive visualization, getting from human the feedback, going back, changing the visualization, getting the human feedback, something like reinforcement learning. That is another area. How can your visualization may be made more interactive? That is another area for the researchers to work on. Outlier detection algorithms. There do exist some algorithms, but there exist some gaps too in identifying the outliers. Sometimes they are not outliers, they are just different data points that has a different meaning, but they are classified as outliers by the existing outlier algorithm, which is wrong. So those problems can be avoided by your enhancement of the existing outlier algorithm or developing a new algorithm. And then data pre-processing. As I told you, there are 3 different kinds of missing data technique. Missing not at random, missing at random, and missing completely at random. I leave it to the researchers to analyze how they work. There do exist missing data imputation techniques for missing completely at random. But for missing not at random and missing at random, there do not exist sufficient algorithms. And missing not at random we cannot say that it can be done with an algorithm, but definitely for MAR we can develop some algorithms. So those who are interested in this research area, they can pursue missing data imputations, how to handle the missing data. And class imbalance. This is again a critical problem. You do get a lot of imbalanced data sets. For example, even credit card fraudulent detection. So most of your transactions will be correct, not fraud. That is 98% will be the right transactions. Only the 2% will be fraud transactions. So in those cases, you have to train your model with only the 2 data points. This may lead to overfit. So how can you balance the data set? What are all the techniques that are existing, like smooth, ADA smooth, many different techniques, adaptive smooth, all these things. So a combination of oversampling and undersampling. Sometimes even the algorithms themselves will handle embedded approaches. So how do they actually work? So are there any gaps that can be? Yes, there do exist some gaps. Can they be solved using your new algorithm, or can you develop any novel algorithm for this complete to handle complete data imbalance? So that can be a research area. And the interpretation of dimensionality reduction. How are the dimensions reduced? See, most of the techniques like even deep learning is all black box. So how can even deep seek AI that came in recently, that is also a black box technique. So how can how can some algorithms or techniques can be developed to interpret them in a much better way? That can be done. And feature selection choice. So we are selecting the features based on some metrics like correlation, some mathematical metrics. They do exist some other metrics. So not only based on that, we do feature selection based on optimization algorithms also. Like you combine these features, how are you getting the accuracy? You combine the set of other features, how are you getting the accuracy? So which is the optimal set of features? For that we use genetic AI, whale optimization algorithm, etc., etc. So, how are there any techniques to get the right set of features, that any enhancements in the existing technique to improve your metrics, or can we develop any new algorithms for feature selection? These are some research areas to explore. And when it comes to data modeling, some parallelization techniques to speed up your modeling, some hardware solutions to speed up, and then regression, local regression can be used, and regression always ends up in local optima problems, so that can be avoided. So how can the regression can be parallelized, how can the answer output can be aggregated, how can the divisive approach can be done, not only with respect to regression, even with the decision tree you can devise the more and more data, and you can devise it and divide it and do it parallelly, and then finally aggregate the result. So any approaches for this kinds of parallelization and division and then aggregation, so that your computational time complexity is becoming less. So that is another area in machine learning. So where you can have your research on. And naive Bayes is more prone to overfitting and underfitting model. It is a probabilistic approach. Many algorithms do exist for to handle this overfitting and underfitting. But how can you do it exactly? How can you improvise it? That is one area. And discretization techniques. How see some algorithms or some machine learning techniques work with the discrete data. So how can continuous data can be discretized? What are the techniques that are available? So that is one again research area. Then noise improval algorithms. How can noise be removed? How can we identify the noise exactly, and how can we remove them? That is another area. And pruning of decision trees. So decision trees, if you leave them, they will be forming, and if you leave them till the end, they will result in overfit model. If you prune them earlier stages itself, they will result in underfit model. So how can we prune them in the right uh, level, so that you are getting a better result? So that is one more thing that the researchers can work on. Then parameter tunings, like finding the right kernels. How can we find the right k in k-means clustering or KNN method? So there do exist rule of thumb method, ELPO method, all these techniques. But how can we have a generic approach for determining k, or how can we have different k for different domains? How can we determine them? That is all very essential research area and hot topic too, and most welcoming area too. And feature engineering methods. So feature engineering is a technique where you combine some features mm, to make your machine learning model very efficient. So some methods, this is a very recent method. Feature engineering has got its attention only over the past 3-4 years. So you can research on more papers on it, and you can work for better feature engineering methods. And optimization algorithms such as grid search, they do exist, but how can they be enhanced in a better way, so that they don't end up in local optima, and they come out with global optima? There should be a balance. So how are they achieving? And this or optimization algorithms are used in many techniques like neural networks for gradient search, like an what you say, the feature selection technique, you use the optimization algorithms. So how can we enhance this optimization algorithm to avoid the local optima problem? So that can be one more research topic. And choosing the right kernel in a function in SVM for nonlinear modeling. That is another data modeling research area. There exist so many research areas. So for clustering techniques, how can we reduce the computational complexity? And how can we explain, interpret the difference between the dimensionality reduced subspace and the original subspace? And then for arbitrary clusters, k-means cluster is a you have a spherical shape, you have a circle shape. So for different arbitrary shapes, random shapes clustering will be there. So how can we have some techniques or algorithms to handle them in a better way? And how can we choose the initial number of clusters? How can we find the cluster center? There are many techniques like single linkage, average linkage, and complete linkage to find out the distance in clustering methods. I'm just telling you the names, giving you the references. I leave out to the researchers to go back and see the research papers based on the words from my mouth, whichever area you're interested in. Understand them clearly, read the state of our techniques right from the origin of the paper, how did they develop this technique, and then come out with a new idea, implement it successfully, then publish your paper. Yours will definitely be done in a high impact channel. So determine the number of clusters, find out the initial cluster, how can we arrive at the cluster center, fuzzy clustering, all this works in this type of technique. So how can we enhance them for your machine learning model, for a better machine learning model? And as I told you, neural networks, they are only abstraction details. We still do not know. They are called black box technique. Actually, we still do not have clear interpretation. So can we do something for that? That is another research area that still researchers are working on. And the balance, getting the balance between local and global optima, not for the optimization algorithms, not sticking into a local optima or neither wander here and there without any ending. So that can be done for optimization algorithms. And the more the number of epochs, the better the accuracy is in models like deep learning. But the more the number of epochs, the computational complexity will also increase. So how can we balance between them? So that is another research area. As I told you, parallelization techniques of different modelings. And fuzzy techniques, if you say, they are more related to specific models, they are not generalized models. So how can we have fuzzy technique for a more generalized model? So that can be developed, which you can apply for different domains and then prove that this is a generalized fuzzy model that can work on different domains. And natural language processing, if you see how they handle the ambiguous words and how slangs are handled, um, there do exist some algorithms, but they do not have more better accuracy, or still they couldn't handle the slangs in different languages properly. There exist some errors. And irony, how does NLP handle irony? So say for example, I'm getting some bad news from the government. So my income taxes increased to this much, the percentage is increased to this much. I'm giving somebody is giving a sentiment like, wow, that's most welcome. Doesn't mean that it is really welcoming. It means he's just giving an irony. It is something that is disliked, that is not welcomed by most of the individuals. It is an irony, but NLP takes it as a good sentiment. It should not be classified as a good sentiment. So how does it handle irony? How can it do so? How can it handle? How can it detect misspelling? All this can be done with NLP, or some research areas with respect to natural language processing. And my friend on who is going to do the FDP on 5th, I think, he is an expert in NLP. He will get you more details into it. And then comes the transfer learning and reinforcement learning. Transfer learning is like you are having a model, you're just transferring the knowledge of the model to another model. So that is transfer learning. And reinforcement learning is like where you incorporate the human feedback and you do the learning for the model. So these are some areas that are still not explored to a greater extent. So for researchers, these are left to the researchers for clear exploration. And NLP should be able to handle multiple languages. That multilingual capability is not still incorporated in most of the NLPs, and dialogue-based systems should be fine-tuned perfectly. So you have a chat with chatbot. Sometimes it comes to the same set of questions again and again. So that rounding is still there. So how can you avoid such things? So that unstable models due to repetitive inputs. And some people, they particularly try to create malicious attempt to your Gen AI to prove that this is not good. So again, like using prompts, how can you more arrive at, uh, predict what the user really wants? See, I booked a ticket, the flight is cancelled, but I haven't received my amount back. When will it be credited? As simple as it is. For this, I have seen a chatbot roaming and roaming. What do you need? What do you need? I'm not understanding you clearly. So at times the customers get pissed off. This is not what we really want from our Gen AI system. So how can you handle such instability in the models, such repetitive inputs? So these are some areas to explore in NLP. I think I'm done with the presentation. So the case study is pending that I'll go through quickly. So you have any questions, or shall I move to the case study? So what we have seen is the data scientist. What are all the steps in data science? So what are all the skill sets that a data scientist requires? How can you incorporate it as a curriculum? What are all the challenges, and what are all the possible solutions to address the challenges? And what are all the research areas for the which will be useful for the researchers to dig deep and give some good publications, come out with some best quality research or patents. So the research area, I know it's a large and huge that I have given to you, but use this as just a keyword. Go back, search them, work on your area of interest, come out with very good interests. Great research ideas. So any questions? So if not, I'll take you through the case study quickly. Yes. Questions, if any. If you feel that there is something that you need to explore more, some research area you need to understand in a much better way, you can always connect with me through LinkedIn also. You can contact me privately, separately also, to in case you need any guidance. So to the extent that I'm feasible at, I have my time allocated, I'll definitely come out with some help.
Hello, ma'am. Good afternoon.
Yes, ma'am.
Ma'am, like to do research in machine learning, ma'am, any textbook you can just suggest, ma'am, for research oriented, ma'am?
For research, as such, there is no specific textbook, ma'am. The only available resources is online, and lot
Okay,
of research papers. You have to
papers.
go through lot of research papers. So machine learning is a broader area, right? So you need
Okay,
to
ma'am.
choose on particular area which you want to address. So like
Okay.
now I have told you so many areas. So
Yes, ma'am. Yes,
if you take a class imbalance problem, for example, take that problem. So
ma'am.
if it is that problem, you will be having lot of
Research
papers
paper.
related.
Okay, ma'am.
Take just the three papers, recent 3 year
Okay.
papers.
Okay,
Only the
ma'am.
3 papers you take, and
Hmm.
then the first origin paper.
Hmm.
When if you read those papers, you will get the origin. See, the first method that came for class imbalance handling is SMOTE method, SMOTE. It
Okay,
is
ma'am.
oversampling method. So find out that paper, that origin, you
Hmm.
read it clearly. Only that
Okay.
paper.
Okay,
And
ma'am.
then the recent 3 years paper, you read it,
Hmm.
what they have done, what are all the advancements that they have done. Then
Okay,
you
ma'am.
would idea about something more, and you will get an idea about how we can approach this. That will
Okay,
be
ma'am.
There is no specific textbook, ma'am. There are a lot of online resources available, and only research papers, reading more research papers will help you get a good idea.
Okay, ma'am. Thank you so much,
And
ma'am.
not only research papers, even blogs will help you. Blogs
Okay,
and
ma'am.
media and stuff. Yeah. So any other questions? Okay. So let me take you through the small case study that shows you how an implementation as a data scientist is done. If you're incorporating your research idea, you have to have your own code. You have to have your own function, own library. So this, what I did is, here I'm actually uploading a file. What is that file? Is that my university ranking database file. I'm just reading that file. So I got the database file. I got the data set from Kaggle only. So you know Kaggle is a good data repository. So I got it from that. So I have my data set ready now. So it is in the form of CSV file. I've just got the data. You can see the data now. I have read the CSV. So you have some features like what is the world rank of that university, what is the institution, where it is located, what is the national rank of the university, what is the quality of education, alumni employment, quality of faculty, research output, quality publications, influence, citations, and scope. Just give me 1 minute, ma'am. Just 1 minute. I'll unmute. I'll come back. I'm sorry, my daughters have to go to school as it's 8 in the morning. That's fine. Okay. So we were running through the database. So we have downloaded the database. So we could see this is the university rank. This is the score for each university. And based on the score, how is the ranking done? So the score is 100 for Harvard University. So the rank is 1. And where is the location? What is the national rank for that university? And the lesser this number, the more quality it is. So quality of education, it is ranked as 2. And alumni employment, it is ranked as 1, meaning almost all the Harvard University students got their placement. And quality of faculty is number 1. Research output, number 1. Quality publications, they are number 1. Influence is, this is SCI index papers. Influences some other references like conference papers and some other papers which are not Scopus indexed. And this is the citation score. And quality of faculty is again the faculty awards that they have got, some things like that. So research output is again based on the number of publications from the faculties and number of patents, something like that. Okay. So we have around 1,000 universities. So starting from 0 till 999, which means there are 1000 rows and 12 features, 12 different columns. We are going to see which are all the attributes that are contributing to the score and thereby the university ranking. So let us do. Okay, now for example, I want to see only the first five datas. We generally see the first five rows, that is the head. Head means first five rows. To see how the data is, I mean, what is the range? The fields are all like they are strings or they are numbers, or how do they, to get a general idea of the data basically. And I have used df.info. This is data frame information to see. See, these are all the values of this five data. I mean, the first five comes for Harvard, Stanford, MIT, University of Cambridge, and University of Oxford. So now this is the information of all the features. So information in the sense, so world rank, it is of type integer, and institution, it is of type object, location is of type object, national rank type integer. So what is the data type of all these different features? Are there any null values, I mean missing values? So non-null means all these are non-null. Okay, so remember that we have seen here something like hyphen hyphen hyphen. So hyphen means it is missing. So let's see. But here it is showing it is non-null, means nothing is missing. Let's see what is the problem. Okay, so there is one feature of type float. There are two features of type int. There are 9 features of type object. So this is how our data set is built with. And remember, with the type object, we cannot do any arithmetic operations, or we cannot do any graph plotting also. We have to convert them into int or float to work on them, to manipulate on them. Okay, so let's see what we can do. So as I told you, they are all non-null. So let's check if it is not null. So here it is saying, is there any data that is null? Find the sum of them. So nothing, none of the feature, it is saying there exists a null value. So it means all the data are pakka filled. There is no non-null. And let us see. But we have seen some hyphen values that are null. But they are not considered as null because they have hyphen there. And the same way, there are some values that are greater than 1000. You could see here in the head, greater than 1000. So this is not greater than 1000 means with this you cannot do any arithmetic computation, right? It is an object. It cannot be converted to int also because of the sign greater than. So what we are doing is basically, I'm just making a copy of the data frame and I'm replacing this greater than 1000 to 1001 so that it becomes an int value. So with integer feature, I can do some operations. And then np.nan, that is np is numpy. So this hyphens, I'm making it as null value. I'm converting it as null value because hyphen means they are actually missing. But since they are hyphen, they are not considered as null here. But they are actually null. They do not have any values. So I'm just making it as null. And this one I'm making it as 1001 to make my operations easier. So these are not automated. These are not AI. This is a data scientist job process. So data wrangling, data pre-processing. Okay. And here, now we are checking if there are, oh, I have not executed this. Okay. So I'm making a copy of the data. See, now I have replaced all the hyphen values with NAN. You see 995 quality of education. In the top, if you see 995 quality of education will be hyphen. It is replaced as null now. And alumni employment greater than 1000, it is made as 1001 here. Okay, so it is made as 1001 here. This is NAN, this is 1001. So I have made the necessary modifications or changes. Now, I'm going to check how many null values are there. So now if you see, since I have changed all the hyphen to null values, you could see that quality of education is having 597 rows as null, and quality of faculty is having 731 rows as null. Means they are made as hyphen. So now I'm converting it into list because only in list I can do certain operations. So that is what I told. You need to have programming knowledge to understand the data types of Python. What are all the operations that I can do in a data frame? What are all the operations that are supported as a list? What are the operations that are supported in an array? What are all the operations that are supported in tuple? What are all the operations that I can do in set? So for me to be easy, I am converting it into list because certain operations can be done only in a list. So now what I have to do is, so see, I would see that here, I'm converting it into list. See, I'm making it as a list. I can see here that this is misspelling. This is misspelling. Something wrong in these things. So what I'm doing here is this thing and this thing, I'm replacing it with the proper title, quality of education and quality of work, faculty, because this is very clear that this is something else. Okay, so I'm just correcting the data. This is that misspelling, correcting all those things that comes under data wrangling process itself. So now you see the columns, it is all corrected. So this is how you're processing the data clearly. And now what I'm doing is location and institution. I'm taking it out. This data types as objects because this data types are objects. All I mean, location and institution is string. So you will say the institution name, all that are strings, and you can't convert them into int or float or something. But the rest of them are objects, and you have to convert them into integer or float or something so that you can operate on them. Otherwise, you cannot even plot them in a graph. If they are of object type, you cannot even plot them in a graph. So except these two, I'm converting the others as float. Now you see the data type, except these two, which are objects, all others are converted. These two were already existing as int, so I just left as it is. So the rest, all others, I have converted into float so that I can use them for my exploratory data analysis. Okay. Now I have to fill in these two columns because these two columns have a lot of null values. Right. So these two are the columns that I have to fill. Now, how am I filling? I'm filling the null values of these two columns with mean value. So whatever is the mean of quality of education, for all the null values, it will substitute that mean value. For all the null values in quality of faculty, it will substitute that particular column's mean value. So now you see, after substituting, is there any null? No. See that 597 and 795 nulls. It was here. Yes, these nulls have become zeros now. They are all substituted with the mean values. Now, I'm just, for me to check, is there any value that is greater than 1000? Because we have already filled them. So we are just ensuring that there is no value that is greater than 1000 because we have already substituted them with 10,000, but still we are checking. Again, I'm checking if there is any dash value. I've already substituted it with, made it as null and then substituted with the mean, but still for me to assure that I'm checking once again, there is no null value. Now again, I'm taking that information. Okay, everything is perfect. There is nothing null. The data types is also perfect, so I can work with them. So just for my knowledge, I'm just checking what is the maximum value of quality of education? 666. What is the maximum value of quality of faculty? 303. So research output, alumni employment, quality publications, influence, citations, score. What are the maximum values in each and every category? I'm just checking it. This is for my own knowledge, the range. So this is, I would like to convert the country name and the continent code. So basically, I'm getting the continent name for that particular country. So America, how much? I need to just check how much in Asia, how many or in how many universities in Asia are in the top ranks, and how many universities in Africa, how many universities in America are having top ranks. So there is a I'm installing the library. These two libraries I have to install because I'm converting that country into continent code. Okay, I'm making a copy of it and I'm using this functions. These functions are inside this package. So I am making use of it and I have successfully installed and converted those into continents. Now you see about the world rank and national rank. I have taken only the top 25 universities, not top 40. I have written it wrong here. It is the top 25 universities around the world I have taken for analysis. See, this is how my exploratory data analysis is. See, this is the world rank and this is the national rank. These are all the top 5 universities in the world and national rank. You see, the more, the lesser, if they are ranked very well in a nation, they are also ranked well in the state for most of the universities. This is number 1 in nation, this is number 1 in state. So this is in nation, it is ranked less, whereas in worldwide, okay, it occupies a 4th position. In its nation, it is like little less. So it's almost giving you a view that those universities that are ranked well in the nation are also ranked well in the world rank. Now, I would like to check if there is any relation between the research output and the score, because I want to check how a research faculty's research are contributing to the university. Let me plot a line graph and check if there is really any contribution by the research score. Wow, S. So see here, I've just taken the top 25 universities. See, if they are ranked well in the research, number 1 position, their score is high. If they are ranked little less in research, the score is little less. So definitely there is a research output that is contributing to the score. Next, I'm checking whether there is any influence on quality publications and score. Quality publications, influence, and citations to the score. So here I have used this because last one was just a bivariate analysis, but this is a multivariate analysis. That was doing only the relation between the score and research output. This was doing the relation between 3 different variables and then the research output. You see, the score is very high and it is ranked good in the citation also. Number 1 in citation, the score is 100. So here you see the quality publications, what is the rank, and the score, what is the score. So here you see, so definitely this are contributing, but influence and citations you could see they are positively correlated with each other. You see this red and this green lines are almost coming together and together, whereas the blue line is little here and there. So there is more a relation between the influence and citations. And same way, I'm just checking whether the quality of faculty, quality of education, and alumni employment is impacting on the score, has any impact on the score. They do impact, but you can see that these are ranked well with respect to the quality of education, but still their score is less than 70. They do impact, but not a great impact as we had in the previous case. So these factors are contributing less, whereas these factors are contributing more. research factors are contributing more for the ranking, whereas these factors are contributing little less. So now let's see. The top 15 universities, I'm just doing a comparison, how they are. So what is the national rank? What is the quality of, see, for example, this is very clear, University of California, okay? What is the national rank? What is their quality of education, where they are placed? How about the alumni employment? How about the quality of faculty? How about the quality of publications, citation, influence, and research output? You could see that alumni employment is something that is not actually contributing more to the score. They are ranked, I mean, the score in alumni employment is more, but they are ranked 1, 2, 3, 4, 5, 6th in the world rank. Okay, so the results are little may not be as expected as you. I mean, as expected, it may be different also. So that we can predict only by exploratory data analysis. How much, which factor is contributing how much. And see, this California Institute of Technology, the thing is very high when it comes to alumni employment. And then I'm just checking for the citations and world rank. This I used Plotly Express. I just wanted to show you how the Plotly works. See, these are the different countries, and this each color represents the different countries. The citation score, the world rank, where they are placed in the world rank. So you could see here, you could get some clear idea. Like this blue color represents USA. They have good citations mostly. Based on the citation, they are getting the world rank in a much better way. So this South Korea, this universities are little less when it comes to citations. Okay. Out of my own curiosity, I just wanted to find out how many are in Asia ranking. So this is just head again. This is Asia. So how many in Asia are there? See, 292 universities in Asia are there in this world rank. So out of my own curiosity, I also wanted to find out. I also wanted to get a model. See, I think there is some in India also. University of Calcutta in India, which is 69.8, which had a score of 69.8 and the ranking of 996. Okay. So now I have developed my model, random forest model, on this data. So I dropped these features because score is what we have to predict. Location doesn't contribute. We know it very well. Institution, name of the institution doesn't contribute. The continent doesn't contribute. World rank is something that we need to predict based on the score, and national rank is also something that we need to predict based on the score. So my predictor variable will be the score. These are the features that I am dropping it out, and with the rest features I am trying. So I have dropped these features, and with the remaining features like quality of faculty, quality of education, alumni employment, all those, I'm just doing the training split data set and a random forest I'm creating. I'm trying to build a model, data modeling. And this was my mean square error. Definitely this is not the best model. You could still try with the different models, different test sizes, different cross validation, and you can also adjust the hyperparameters and come out with better model. This is just to showcase how a data scientist works. I have designed this. And you see, I'm giving a test data. So how does it work? Let me see. See the score. So for those universities with the quality of the first one with quality of education in a good position, quality of faculty, research output, alumni employment, quality publication and influence and citation, this is really having a good rank in all these things. the score is good than others. So let me change, for example, something and see how the score is affected. Quality of faculty, I'm changing to something. Let me see, from 90 it has become 93. So if your faculty is getting more awards and you are improving the quality of faculty, you will get a better score. So let me see how alumni employment is affecting. See, for example, I'm giving 5. Again, your score the same way how a quality of faculty is contributing, alumni employment is also contributing. Let me say in research, I have got number 2 position. So my university score is this. So I have to retrain the model. Yeah. So now I'm increasing this few of it. Say for example like this. Sorry. Let me see how influence and citations have made. See, the influence and citations have made a huge impact on my score. From 93, my score dropped down to 84 because of these 3 alone. So the quality publications, the influence, the citations contribute more than this quality of education, quality of faculty and alumni employment. So this is how you can adjust your parameters and check how you can improve the score. And accordingly, you can recommend to your management what are all the factors that you have to work on to improve your university ranking. This is one small case study. So you can do any case studies if you want. See, I'll show you an example of how a coding is being generated from GenAI. So I'm just adding a code cell, generate with AI. Say for example, this is TF3, right? Create a model, create a linear regression model on DF3. See, it's created. So your GenAI is created. Your duty is just to check if it is right. So where you have to adjust your parameters. What is the mean square error? If it is giving any error, see this is much more than a random forest. If it is how much you can change something, which model is better. See, that's what I told. Now with Gen AI, your coding has become very simple and use code with caution. It is given. See, you can't just blindly have this. You have to understand it, what it is doing and how you can change things, and you can do it in a much better way. So this is the case study of university ranking, which are all the factors that are affecting how you can improve your ranking by adjusting which factor to which level. So what you can contribute, how much you can contribute, so all these things. So I hope I've given a broader overview about the data scientists, their role, what are all the steps involved, how it can be accommodated in academic, and how it can be pursued as a research, and how actually data scientist works a normal case study. So it's nothing like a rocket science. Even rocket science is easier if you approach it in the right way. Thank you so much for the opportunity. Think I'm done. Any questions?
No, ma'am. Session was good.
Thank you so much, sir. So if you have any individual questions or you require any help also, you can contact me via LinkedIn. I'm available there. So any other help also you require, you can contact. Hope this session was informative. So I'll hand over to the person. Thank you so much, ma'am. Thanks for the good feedback. I'm happy that I'm able to contribute to the academia. That too for my motherland.
Yeah, good afternoon, everyone, and good afternoon, Dr. Gayatri, Madam. It's Manoj here.
Thank you, sir.
Yeah, first I would like to thank you for sharing your valuable thoughts and knowledge during this session. And it's truly expertise and guidance what you have shown in the case studies. Truly appreciated and hope that will be useful in the research work of all the faculties who are attending. And I would like to mention a special thank to you for adjusting your timing as per our Indian convenient time. So I really thank you for that, because I know I'm seeing your desktop, it was -6 degrees. So I really thank you guys, Gayatri madam, for accepting our request. So and also for a wonderful session, one wonderful session. Thank you very much.
Thank you, sir. And my special and extended thanks to Dr. Manoj, sir, for all his. So it's very difficult to see a person who is having such a broader vision in giving a quality of education to his faculties and students in a very great position. I really appreciate it, sir. Um, so thank you. Hoping to work more closely with many academic institutions and more closely with probably GCM also. So whatever help you require, please let me know with respect to AI or ML domain. Ready to help you. So any other faculties in any other academy also, if you require any guest lectures or special sessions or any research guidance, we'll be more happier to help our motherland.
Sure, madam. Thank you very much. Thank you.
Thank you, sir. Thank you. So I'll close the session. Thank you.
Yes.
Thank you, ma'am. Thank you, everyone.